You're one of the few doctors out there. I mean, I just had a conversation with Andy Weil yesterday. He talked about the body's own healing systems in a very kind of high level, but you go really granular, and you're one of the few doctors to talk about how the body has its own healing mechanisms and that we're not doing enough to activate those healing mechanisms. We all know that we have that. If we cut our skin, it heals, right? How does that happen? It's not a miracle, it's biology. And that doesn't happen only on the outside, it happens on the inside. So how do we activate our healing systems? What are those healing systems, and how do specific foods activate different healing systems?
Yeah, well, okay, so let's follow a piece of food that we want to put in our mouth, right? So we're chewing it up. Guess what? Our food actually interacts with the healthy gut bacteria that lives in part on our tongue. So our tongue has healthy gut bacteria as well. The gut starts in the mouth and it goes all the way to the anus. And so when we eat foods like a beet, for example, or a piece of spinach, and we're chewing and enjoying the beet, it turns out that the nitrogen that the plant naturally absorbed in the soil gets converted by our gut microbiome that live in the little recesses of our tongue. So think
Wow.
about it. You get up in the morning and you're brushing your tongue. Okay, now it'll grow back. Okay,
I don't do that. I think it's supposed to. Who brushes their tongue? I don't know. It's a
well,
thing.
but people actually use
I know.
this like dentists
Tongue
give
scrapers.
mouthwash,
Yeah. Yeah.
and they actually kill all the bacteria in your mouth with the intent of actually preventing cavities. Well, look, if you have good, healthy gut bacteria in your mouth, which is one of the body's health defense systems, it actually works for you. It doesn't work against you, and it actually suppresses cavities by itself. So, eat a piece of spinach or beet, chew it up. The bacteria actually change the nitrogen into a form that when you swallow it, gets absorbed in your stomach. We're still following the food along as a chemical form that is nitric oxide. Now, nitric oxide suddenly is absorbed in the stomach in your blood vessels, carried by the circulation, which causes vasodilation. Now your blood pressure falls. And why is that important? Because for hypertension, one of the big causes of stroke, for example. And for every single point we can lower that top number in the blood pressure, 140 over 90, we decrease our risk of stroke by 5%.
Wow.
So it's meaningful. So, a nitric oxide also has other benefits for our body as well. It actually calls another defense system stem cells to help us heal. So the stem cells live in a bone marrow, have nitric oxide. Now they fly into the bloodstream like bees in a hive looking for organs to actually repair. So just eating a spinach or beet, for example, will immediately help our cardiovascular system, help our regeneration system, and also can help grow blood vessels that we need to heal. That's just one example of how we can track kind of like it's like being going on safari in Africa. You're in a Jeep with a camera and trying to follow on what's going on. And we're beginning to understand there's this, incredible journey that happens in our body with foods that we eat, and they activate our health defenses.
Yeah. One of the favorite things I love to talk about is how we've sort of lost our nutritional wisdom. And historically, we were attracted to the right foods. Now we're not, because our brain chemistry, hormones, and our microbiome have all been hijacked and are sending chaotic signals to our brain about what to eat. But historically, we crave the right things. And when you eat in a certain way, you don't actually look at food the same way. I mean, when I see processed food, or I go by a Starbucks and I see all the muffins, it doesn't look like food to me. I'm like, well, why would I eat that? It's like eating a rock. Like, it just doesn't even interest me. And it's not because I'm depriving myself. It's because I've changed my nutritional wisdom in my innate biology to crave the right things. And what happens is when you look at this phytochemical story, the flavors in our food come from these molecules. So actually, the more flavorful a thing is naturally, not when you put all kinds of stuff on it, but naturally, actually the better it is for you. The more medicine is in the food.
Well, and when you treat the food with medicines, like putting pesticides on foods, for example, you might make it look a little bit nicer. But in fact, I always like to talk about this example. I used to be a skeptic about organic foods. And the reason is because there was so much marketing on there, and telling me to have less something bad doesn't attract me. I want to know, I want a different reason. And so I started talking to horticulturalists, and they told me something really important. They said, that a plant like a strawberry or a coffee bean, when they're existing in the wild, and the pests, the little bugs, insect nibble at their leaves and stems.
Yeah, they produce more chemicals.
They produce more chemicals because they view the little nibbles as an injury. So,
Yeah,
in response, as a wound healing response, they create more ellagic acid in a strawberry or more chlorogenic acid in the coffee bean.
yeah,
And sure enough, when you actually put pesticides on a strawberry or a coffee, which is conventionally grown, you wind up, they don't need to make more of those chemicals. And so what you wind up having is something that looks like a coffee bean and something that looks like a strawberry, but it's actually relatively deficient in what Mother Nature would have otherwise served up that's actually good for our body. And so, I started to change my mind, more good as opposed to less bad.
yeah. It's
That
true.
now that actually tracks me.
It's true. I think the other point that to make on the back of that is that when we put these chemicals on the soil, it kills all the life in the soil. So when you till the soil, when you put fertilizer on it, when you pesticides, herbicides, it literally kills the microbiome of the soil. And the plants are in an intimate relationship with the microbiome of the soil. They're feeding the microbiome by bringing in carbon dioxide, turning that into metabolizable starch. And then in turn, those bacteria are helping the plant extract nutrients from the soil, minerals, vitamins, all kinds of stuff that the soil has that benefits the plant. So it's this mutualism that occurs that if when we break that cycle, we end up, as we see now, with many of our fruits and vegetables having dramatically lower levels of nutrients than they did even 50 years ago. And that terrifies me because these nutrients are not just kind of window dressing on our food. They're critical molecules that are, they call them vitamins, vital for life. That's what vitamins that they call them. And that was the whole point of these things, that you'd get sick and die if you didn't eat them. So we're in a
Yeah.
kind of a pandemic of that.
Well, and I totally agree, because I think you and I were at a meeting once where we both heard there was like only 60 harvests left
Left, right.
in topsoil in America. Like, just
Yeah.
think about that. Like, you can count that off, with a family member on hands and fingers and toes. That is truly scary. And so I think that the greater the more we're alert to the fact that if we want to take good care of ourselves, we don't want to get more complicated. We want to get more simple. We want to
Yeah.
actually follow our body's instincts to eat those things that are more natural, that are less processed, that are plant-based. And, ultimately, you were talking earlier about, animals eating plants, even these delicious seafoods, oily fish that people actually eat. At the end of the day, it's big fish eating smaller fish, eating plants. And that's where the
Exactly.
omega-3s come from.
Exactly.
So,
It's algae, right?
exactly.
Exactly. Yeah. It's so true. I think the interesting thing that I've been learning about is that the animals left to their own devices, they'll eat 3 or 4 main crops or foods. But if they're free to eat and forage for a wide variety of plants, they might eat up to 50 or 100 different plants, and they'll sample little bits of each one, kind of like taking their vitamins or their daily pharmaceutical drugs. And those animals, so if you take a feedlot cow, it takes an enormous amount of investment to keep it healthy. Antibiotics, hormones, all kinds of, very aggressive measures because they're not eating their natural diet. And the molecules in there that we want aren't there. And there may be inflammatory molecules. When you take a grass-fed cow, better, but if it's only eating 1 or 2 kinds of grasses, that's not great. And they need extra support. Whereas regeneratively raised cows foraging on maybe 100 different plants actually don't need medicines, don't need antibiotics, don't get sick. If the plants are the right plants, they actually grow to their ideal weight as fast as feedlot cows, and don't release as much methane. I mean, it's really fascinating when you get into the science of the biology of how much the interrelation between soil, plants, animals, and humans exists. And
And the
it's
concept of
unbelievable.
diversity, which you're talking about, is so important, right? Because we do want to protect the species and the diversity of species in our planet. But actually, this is how we're hardwired as well. Our human body, loves diversity. Our gut microbiome wants to eat lots of different things. Our health defense systems, our 5 health defense systems, all crave different types of stimuli to activate them, to keep them kind of agile and active and in shape and working on our behalf. And here's, I think, the really good news for people that are watching this is that ancient cultures, ancient food cultures that revered, treasured tasty foods, mostly plant-based foods, actually understood this. And that's why so many of the foods from the Mediterranean or from Asia, if you go back and look at traditional foods, like, I mean, you and I talked about
Yeah.
this before, this idea of Mediterranean cuisine, like there's a lot of unhealthy eating that goes on in modern Mediterranean countries today. We're talking about traditional eating patterns.
Yeah.
Same thing in Asia. We're talking about going back to basics. And so, we're entering this era where we're, in a way, I think that we're all kind of shedding the artificial skin that we've grown over the last 5 decades.
Yep.
That what we are sold in media or in the supermarket is actually better for us. And when you shed your skin, you kind of get back to basics. The more authentic instincts that we have about what we should eat happen to also taste better as well.
It's so true. When I went to a Chinese doctor the other day, and I had just a checkup. I just wanted to get my pulse checked and get a tune up. And afterwards, she sent me a prescription, which was after feeling my pulse and seeing where I was out of balance. She says, "Oh, you need to build up your blood for this or that or the other thing." So she said I should eat bison and beets and duck and liver and cuttlefish, avocados and black sesame seeds. And then she said I should eat walnuts and almonds and woodier mushrooms and all mushrooms, olives, natto, and seaweed. And of course, she said cherries, goji berries, mulberries, persimmon, and then all this other Asian food like daikons, lotus root, burdock, mountain yam, sweet potatoes, soba noodles, oily fishes, and so forth. And I was like, yeah, she's giving me a drug prescription because each one of these foods, and you probably could talk about each one of these foods for an hour in terms of what's in them. In terms of the way that foods and drugs work together, I think you were sort of bringing up a very interesting point here. I think there's a lot of conversation about drug interactions and how you shouldn't take certain things with certain, like people say, oh, don't have fish oil if you're on a blood thinner, and it's more negative. But it turns out that there's a lot of kind of power in combining food with medicines to activate the power of the medicines, but also to mitigate some of the effects and side effects of the medicine because they contain compounds that help to benefit.
Yeah, well, so what is the first thing that doctors learn when they enter the clinical phase of medicine is that old adage, first do no harm. Well,
Mm.
I actually think that's the wrong priority. I think the first thing we should do is to deliver benefit. And if you flip that around to first deliver benefit, all right, why are
Mm.
we thinking about the bad stuff when we can actually focus our minds on the good stuff? If you're going to first deliver benefit, you have to think about food. And this is where, the reliance on the prescription pad that so many people encounter when they see their average, their primary care doctor. I think every patient knows that there's something that's not being discussed. There's something that is so important that isn't being part of the dialogue. Well, I can tell you that my mind opened on food and medicine, not food versus medicine.
Yes.
Right. So you got these kind of extremists who are, the guy that quit clinical medicine. They stand up on a soapbox and they wave a frond of kale and they basically say, eat this and everything will be cured. And I think that is as wrong as somebody who only writes prescriptions.
Absolutely.
We all need to do good, first deliver benefit. What we need to do is to think about all the tools in our toolbox we can give them. And so, one of the studies that I thought was really interesting was done by the University of North Carolina, where they were taking young, healthy people who were just getting a flu vaccine, wintertime flu vaccine. And they wanted to see if they gave them some food on top of that, it would make a difference in terms of how well their immune systems responded to the vaccine. So they actually took broccoli sprouts, baby 3 to 4 day old broccoli plants, which contain lots of sulforaphanes. These are the natural biochemicals. Broccoli sprouts contain 100 times more sulforaphane than the grown-up broccoli.
Wow.
And so you turn them into a shake, and they just gave them 2 shakes to drink every day. Plus, they got the flu vaccine, and they gave half of the people a placebo shake with no broccoli sprouts. Right? Probably didn't taste very good. And then they swabbed their nose to measure the number of bacteria or viruses that were present, flu viruses, and then they did a blood test. So this is just like you would do in a pharmaceutical trial. They took out blood and they measured their natural killer T cells, which is what your vaccines would do. And here's what they found. They found the people who had the flu vaccine plus the shake had 22 times more of the natural killer T cells.
Wow.
Like
Like,
you
just for
can't.
people listening, that's 22,000% more. Like, that's an insane result, because we get excited in medicine when we see a 20% improvement or a 30% improvement. We're talking about a 22,000% improvement. There's no drugs that do that.
Right. And we think about like how to make the medicine do its job better, right? Well, look, here's the difference between foods and medicines, and we're talking about making them work together. Medicines don't give you joy. They give you some effect that you hope to have. Foods can give you that effect and the joy as well. And then when you put them together, you're getting more effect, and you also get a little bit of the joy of life as well. And so that's one of the studies that I always refer to say, like we can't ignore food as medicine. And the other thing that I think that is, I'm a cancer researcher. I've done a lot of cancer research over my career, and I've had cancer in my family. I talk about my mother, who actually, had all of her cancer successfully eliminated by immunotherapy, using her own immune system to get rid of it. And we had given her pomegranate juice. We'd given her other foods that actually helped to grow good bacteria. Well, the latest study that I think is a jaw dropper was published in Nature Medicine. It was done by the MD Anderson Cancer Center, one of the top cancer centers in the world. Jim Allison, who's actually one of the researchers, won the Nobel Prize for his work in immunotherapy.
Yeah.
That group is studying the immune system, the microbiome, what you eat, and cancer. Like it's sort of like the holy quadrinity of what we want to actually start to do in cancer research. So here's what they found. They took 200 patients who had malignant melanoma, a deadly form of skin cancer.
Yeah.
And these patients were getting immunotherapy, a kind of infused immunotherapy that actually works. When it works great. The problem, only about 20% of people respond to this type of immunotherapy. So they wanted to find out what the difference between responders and non-responders were. And this is starting to be the pattern of the kind of research done in this field. They found that responders who benefited from an immune therapy that jack up your own immune system to go after the cancer, and therefore you do better. The cancer starts to go away and you live. Had one bacteria that the ones who didn't respond didn't have, and that bacteria is Ruminococcus. Now, on a past podcast, I talked about Akkermansia. Well, Ruminococcus is starting to pop up as another significant player in the microbiome space. Now, I started to take note of Ruminococcus about a year and a half ago during the pandemic. People were studying, why did some people have more antiviral cytokines in their bloodstream if they weren't getting COVID? And it turned out that those people had more Ruminococcus in their stool as well.
Wow! So
here
not
you
only
have
cancer, but also COVID.
Yeah, and so what was interesting is that in the study in China that found this during early days of COVID, also asked what were these people eating. And in China, the study for the COVID study showed that the people with more Ruminococcus and more interferon gamma, the natural virus killer, they were drinking more green and black tea, not just green tea, but black tea. And they were having more omega-3 fatty acids, both from plant-based foods as well as seafood. Now, flip back over to the
basically
cancer.
Japanese food with sushi and green tea is a good thing.
Exactly. That's the carryout. The cancer study is much more sober, because now we're talking about a different kind of life or death. And the surprise with this Ruminococcus bacteria, now what they did is they actually asked the people what they were eating. And because the microbiome, of course, is strongly influenced by the food we eat. Turns out that these people were eating many different, mostly plant-based foods with tons of dietary fiber if they were getting Ruminococcus, if they were responding. And so then they began to calculate how much dietary fiber you would need to get an effect. And what they found is that for every 5 grams per day of dietary fiber you ate, how much is 5 grams of dietary fiber? That's the average amount you'd get in a medium-sized pear. A pear a day would give you 5 grams.
And by the way, the average American eats about 8 grams a day, which is terrible.
But even 5 grams in this setting would actually lower the risk of tumor progression and lower mortality by 30%. So now they calculated out, if you actually had 20 grams, up to 20 grams of fiber, you really maxed out your ability to actually respond to
Wow.
a cancer medicine. And so every cancer patient always asks their oncologist, "Hey doc, what should I eat?" And oftentimes they say, "Just eat anything. Go to Mickey D's or whatever."
Or they say
And
eat ice cream and milkshakes, and it's like
we,
terrible.
this is where science is. Science is giving us the answer to those questions that patients want to have. And I think that this
Mhm.
is what responsible doctors who are on, who are current and who are forward going. This is
Yeah.
where our society has to go.
Yeah.
It's beginning to get those answers to be able to tell patients how they can help themselves.
Well, it's interesting, William. We talk about dietary fiber, but that's a very big bucket. There's soluble fiber, insoluble fiber, prebiotic fibers. Did it matter? And how did they figure that out?
They were looking at mostly fruits and vegetables, and
Mm.
I think these are mostly insoluble fibers, or sorry, soluble fibers that were in this study. And so this is now the next layer. So real scientific research doesn't deliver all the answers in one fell swoop. You kind of go back and you get back into the batter's box and you hit another one out in terms of research. And so that's really, I think, a place to watch MD Anderson looking at this work that they're doing on the microbiome and diet and looking at the response to cancer therapy. So, I mean, look, these kinds of efforts are going on all around the world, but they underscore this idea that the food that we eat does matter. And it can matter a lot to help the medicines that have been the product of all this research to help get the result that we want to patients. So first, deliver benefit. And I think that that's something that is really important for doctors to hear.
So I think if this is true, and I clearly believe it is, and you believe it is, and I don't even know if it's a belief because it's scientifically proven. I could believe in God or not, but that's hard to prove scientifically, or how many angels dance on the head of a pin. We can argue that all day, but this is science. And given that science, then if food is medicine, how should doctors prescribe medicine? What's the dose, the amount, the frequency, and for what disease is? I mean, it's a whole new field of inquiry, and it really requires a whole new curriculum for medical school that we haven't even come close to formulating. And your book was probably the closest curriculum there is to actually laying that out. So how do we get from here to there? Because right now we're here, and in 10 years, where are we going to be, and how are we going to get there?
Yeah, no, I'm glad you brought up this whole issue of food dosing, because if food is medicine, medicine always has a dose, right? So, like as doctors, we're taught to write prescriptions. What is the name of the medicine? How much do you give? How often do you give it? And then what are we actually looking for? And so,
Right.
to do this, for a drug, you design a clinical trial and you test different doses. There's a completely different way to come at this when it comes to food, and that is to look at the research studies that have been done, and we talked about a couple of them, and then to look at the result and then to calculate based on the result. You kind of work backwards to figure out where did we start from. So I like to talk about a study of 36,000 people. It's a health professional follow-up study that looked
Mm-hmm.
at men who were ultimately, were all men at risk for developing prostate cancer. And they wanted to find out, for the people who didn't develop prostate cancer, what were they eating?
Yeah.
And they had a hypothesis that lycopene in tomatoes might affect prostate cancer
Yeah.
because it's antioxidant, it kills cancer cells, and it cuts off the blood supply feeding cancers. And
Mm.
so when they did the study, they found that men who ate 2 to 3 servings of cooked tomato. Now, what's in a serving? You can calculate this. When you look at the study, it's a half cup serving size. So 2 to 3 half cups of cooked tomatoes. Now you even have a way of preparing the food over the course of a week. That's not asking a lot. 2 to 3 cups of half cups of servings of tomatoes lowered the risk of prostate cancer by 29%. And so now we have an outcome. And again, I don't think it's reasonable to ask people, patients, healthy people, to go into that medical research to dive into it.
Mm.
But for those of us who are doctors
Yeah.
and trained to do this, we have that ability. And so I think that, you're absolutely right. What we need to do is to train up the ability for healthcare providers that patients are supposed to trust, to give them the tools to be able to actually go in and wade into that complicated stuff, to make it simple for patients.
Yeah.
So when somebody asks me about tomatoes and prostate cancer, I just say, look, you want to have, something with tomato sauce in it 2 to 3 times a week, and it only needs to be a half cup. That's not a lot.
Yeah. Yeah. I had a patient once who did not want to take any supplements, and she came to see me and she's, look, I know I need this much zinc and I need this much magnesium and I need this much folic acid and I need this much. And she so basically showed me, she's like, I need 17 pumpkin seeds and I need like 12 almonds. And I was like, wow, that's impressive. Because she literally did the research to find out what nutrients are in the food. Now, hopefully she was getting it from sources where actually the food she was buying had the nutrients that they're supposed to be in there. But it's really quite amazing. And I think, William, I think that most doctors don't understand the power of food. And because, if I said, oh, do you have a headache, William? Okay, well, I'm a doctor. I'm going to prescribe aspirin for you. And you need to take 650 milligrams of aspirin. That will help your headache. But if I just gave you a milligram of aspirin, I would conclude that aspirin doesn't have anything to do with headaches. But we're not prescribing the right drug in the right dosage. And I think we don't see the outcomes that we can see, as such as reversing heart failure, cancer, diabetes, autoimmune diseases, chronic digestive problems, skin diseases, mood disorders. I mean, you just go on and on down the list. And it's like, wow, we're missing this entire pharmacology that is so critical. Years ago, I wrote an article called "Food is Pharmacology: Eating Your Medicine," basically based on this Chinese meal I had in a restaurant in Hong Kong that was like ginkgo nuts and Chinese wood ear mushrooms and this thing and that thing, and everything had its like medicinal properties. And Chinese folks have known this forever. In fact, the word for take your medicine is 吃药, which means eat your medicine, right? Which was the name of my PBS show that did really well. So I think they're onto something. I feel like it's so critical.
I think you're right. And here's something in real time I can tell you that I'm in the process of working on, and you're going to like this because this comes from one of your home-based institutions out of Ohio. So there was a study that did a computational analysis, artificial intelligence, to take a look at what medicines might be associated with lowering the risk of some serious disease, like Alzheimer's disease. And so here is the Cleveland Clinic. They were taking a look at 7 million people's medical records, and putting a computer program in to mine and see like 1,600 different kind of medicines that people are taking, all these different disease states that people are having, and trying to figure out was there any interconnection of the pattern at the genetic level. And what they found was truly amazing, because at the end of the day, and here's the punchline for the study, they found, surprisingly, that men who were taking Viagra, sildenafil, had a 69% decrease in the risk of developing Alzheimer's disease. Wow. Okay.
So more sex means less dementia, or was it something else?
Yeah, clears your mind.
Well, actually, I read a study once that men live longer if they have more sex. The same is true for women, but they have to like it.
Well, so here's the thing. How is it that Viagra, sildenafil, could actually be helpful for Alzheimer's disease? So these researchers went back into the lab. So sometimes we can take an observation, whether it's through dietary studies or through medicine studies, and go back into the lab and check it out. So what they found actually with the Viagra, which produces nitric oxide, the same thing that spinach and beets actually help our body produce, actually stimulates regeneration, and nerves will actually start to sprout new nerves. Okay. And it actually downregulates the gene that creates a protein called tau that builds up and clogs up your brain in Alzheimer's disease. And so now we have going backwards to try to find an explanation for something that a computer helped us figure out now. And this is kind of like the wait for it moment. So what I'm trying to do now is to figure out, on the basis of the doses of Viagra that create nitric oxide, can we then jump to a different silo to say, well, Viagra can create this much nitric oxide. How much can spinach and beets create? Because then we can actually kind of do that, take out the pH for pharmacology and put the F.
Right. Because they have natural nitrates that get converted to nitric oxide in the body.
Exactly. And so now what we can actually do is to try to figure that out. And this is, I think, those of us who are working sort of at an advanced area of food as medicine are really trying to break open new frontiers by doing this kind of research. And what I would say is that it's kind of like mixed martial arts. You don't want to just use one style of fighting, one
Yeah.
set of
Yeah.
moves. You want to use every tool at your disposal
Yeah.
in order to be able to, kind of get that match, win that match.
Yeah, so true. And I think the exciting thing is we are starting to understand how to use medicine from foods in a more precise, deliberate way. And you mentioned the 22,000 full percent increase in the benefit of eating certain foods and the flu effectiveness.
Broccoli
So
sprouts.
broccoli sprouts. I want to take a kind of a little bit of left turn, but not really, because it relates to food and the immune system. And and some of the sort of discoveries you've made around COVID and long COVID right now. We know, for example, our friend Dariush Mazafarian published an article from Tufts research that showed that 63% of cases of hospitalizations and deaths from COVID were because of poor diet, lack of protective foods, too much bad food. And so the question is, with our understanding now of COVID and now this post-COVID phenomena, what are we learning, and what are you learning that may combine both nutrition and also pharmacology to help us reimagine our approach to preventing COVID, treating COVID, and actually dealing with what we call long COVID?
Yeah, I mean, it seems like we've been mired in COVID, in this pandemic, for a long time,
Yeah,
and yet when you really look at it, it's only been about 3
2
years or
years.
so that we've been kind of arm wrestling with this thing, and in 3 years we've learned a lot
It's only 2
from.
years, but it feels like 3 years.
Yeah. Well, the thing is that we started with zero knowledge. And I think
Yeah.
that's what's amazing. And to speak to your point about food as medicine, I remember distinctly staring out the window at the very beginning of the pandemic in March 2020, realizing that, as a medical doctor, as a highly trained medical doctor that actually develops medicines, that here was a moment in human history where we have all this technology, all these drugs, all this knowledge, but we were confronted with a new disease for which we had nothing.
Mm,
Hospitals couldn't offer
mm,
anything. Doctors couldn't offer
mm,
anything. Pharmaceutical
mm,
companies couldn't offer anything. And it was
mm.
just us. And the only thing that we all had to do as humans was to go out and get our food and bring it back home and to prepare it. And
Yeah,
so this was that moment that I started to realize, like, okay, there is a real important mission for what it is that you do, Mark, and what I do, and which is to get that message out. People need to
yeah.
understand, when we could be confronted with something new around the next corner, and
Hmm.
at the end of the day, we have the agency as individuals to make better choices on our own body's behalf for immunity. And so I will tell you the things that I started to look at now. I've also been involved with sort of like the vaccines and antivirals and all that fancy stuff that is in the realm of pharma for COVID. But here's some basic things that everyone should know. What does this coronavirus do when you have COVID? It causes massive inflammation in your body.
Yeah.
There are foods that actually can lower inflammation. I mean,
Mm.
simple foods containing vitamin C lower inflammation.
Yeah.
Strawberries, guava, tomatoes, red bell peppers. These are the kind of colorful foods that actually can begin addressing some of those things. We also know that people who had vitamin D deficiencies actually were more vulnerable to
Yeah.
actually developing COVID or becoming infected with COVID and getting sick. Well,
Hmm.
mushrooms are a good source of vitamin D. And if you actually take a mushroom and slice it and expose it to sunlight in the windowsill before you eat it, the mushroom will actually make more vitamin
So
D.
give your mushroom a suntan.
Not in a suntanning salon, but and don't rub any olive oil until you're ready to cook it.
I love that. No
But
sunblock. But,
no
no
sunblock.
sunblock. But the porcini mushrooms are the most potent sources of vitamin D. And they're
That's
hard to
right.
find. I only had fresh porcini mushrooms when I go to Italy.
Well, the dried ones actually are also still good because not only they taste great, they have a lot of dietary fiber. And if you take a look at dried porcini mushrooms, there's some caps of the mushrooms which are good, but the stems actually have more of that
Mm.
soluble fiber
Yeah.
than the caps do. So you're getting again, go back to ancient food cultures. Porcini mushrooms. Why should you eat them? Because they taste great. And then
Exactly.
let's talk about the other reasons that are equally important. But so you can actually supplement. Use food to get your vitamin D levels up. You can actually have citrus and other foods to lower your inflammation. And then the other thing we're beginning to realize too, that what this virus does to your body is it actually does two things that need to be addressed. And this is relevant to long COVID.
Yeah.
Because most people actually recover from COVID. There's millions of people that have recovered from COVID, but they're walking around, I believe, and the research actually shows, potentially as time bombs, because even when the virus has left the body, it may not have left. It may have actually stay hidden inside your body. So we believe that people who continue to suffer from long COVID, which is this odd syndrome, more than 100 symptoms, they can't be easily explained. They can arise, they stick around and they can even appear a month after you recover from COVID. And they can last for months or years. They can be mild or crippling. We don't understand too much about it, but there are some common themes. Number one, it seems like there's chronic inflammation that's going on in the body. We think the chronic inflammation is due to autoantibodies that the virus stimulates. So this is like COVID kind of like tries to give you lupus, by triggering autoantibodies. And then the third thing we do know that COVID does is it's very sneaky. It gets into your blood vessels and scrapes up your blood vessels cells, the endothelial cells, and damages them. Now, foods can heal endothelium. The Mediterranean diet has been studied with the CardioPrev study to improve endothelial health. Dark chocolate can improve endothelial health. These are some of the foods that we need to think about. Oh, spinach and beets with natural nitrates and bok choy can improve endothelial health. These are important things to think about.
That's what I'm having for dinner: beets and bok choy.
There you go. Hydroxytyrosol, which is actually one of the highest level polyphenols that are found in olives and in olive oil, actually has been shown to interfere with the binding of the SARS-CoV-2 coronavirus with human cells. And so, again, when you stop thinking first about the food and start thinking about the mechanisms, the biology of health and disease, it allows us to kind of step back and look at what's going on and say, all right, if that's what's going on, how do we start to choose the foods to be able to put into play? The 4 phases, everyone is born with the same metabolism, okay? In the first phase, it's 0 to 1. Human metabolism skyrockets so that at 1 year old, when you reach 12 months, your metabolism is 50% higher than what it would be later when you're an adult, all right? So it's like a rocket ship blasting off. Phase 2, that's from 1 year old to 20 years old. Your metabolism goes down, 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 down. Now, why is that important? Because most of us who have had kids assume that when your teenagers are eating 2 meals and bouncing off the walls and growing like a bean sprout, their metabolism must be going up, right?
No,
Wrong.
it's going down.
It's going down, and it descends to adult levels. That's phase 2. Phase 3 is starting from 20 to 60. And you know what the result was? This is the most surprising part. 20, 30, 40, 50, 60. Metabolism is hardwired to be a straight line. It does not change as the hardwiring in our body. And what that means is that 60 can be the new 20 if you allow your metabolism to do its thing. All right, that's phase 3. Now I'm going to come back to that in a second. And then phase 4, the 4 phases from 60 to 90, you do decline a little bit, but only by 17%. So by the time you're 90, all right, your metabolism's basically only less than 20% decrease from what it was at 60 or at 20. All right.
That's amazing.
So it is amazing. Now, and basically what this discovery has done is led us to completely rip up the old metabolism textbooks, and the new ones are being rewritten right now based on this new science. Now, the key part, though, because people say, well, wait a minute, I'm 40 years old, I'm 50 years old, I'm gaining weight. Like, I know this happens. What happens is that when you add the data back, when you add the effect of extra body fat back, you crush the metabolism. So it's not that a slow metabolism causes you to gain body fat, okay, and gain weight. It's the other way around. Our body fat, our metabolism runs this way, but if you undertake behaviors, whether you're inactive, you're not getting enough sleep, you're overly stressed, you eat incorrectly, your microbiome's deranged, what happens is you gain body fat, and it's body fat that crushes your metabolism completely the other way around than what we
Wow.
thought. Like
So being
profound.
overweight slows your metabolism down.
That's right. Not so. So the good news, by the way, with this discovery is that it means that suddenly we have a new ability, a newfound ability to be able to control our metabolism. Because if we can actually right size our body fat, because this is the other point, fat isn't our enemy. Fat's in fact a critical part of our health, except when we have too much of it. So what you want to do is sort of like shave it back down, tune it down, turn the volume down. And as you do that, your metabolism rises because that's the hardwiring in our
Hmm.
body.
Hmm. So proportional to your weight, your metabolism rises, is what you're saying.
That's right. And body size, right? So, and it all depends on your body size as well. So, and by the way, this is important because body size is often viewed as sort of the lead balloon, when it comes to the bummer of metabolism, but that's not really the case. If you look at some of the healthiest people in the world, and I write about this in my book, think about Olympians. You have the little gymnasts, you've got the shot putters, you've got the weightlifters, and they're all champions, even though the body sizes are different. And then if you look at boxing, there's like 14 different weight classes from flyweight to heavyweight, and there's a world champion in every single group. And so those people are super fit. And I think this is the other thing is we need to do is to realize our metabolism is like the operating system in our laptop. Whether you got a 15-inch or a 13-inch laptop, this operating system is still at work. And so what happens is that when we accumulate excess body fat, that's like, confusing your computer and getting it glitchy, then you got to actually clean that up. And I think this is really what there's an opportunity for us to do is to clean up our our body of excess body fat to allow our operating system when it comes to metabolism to be able to run the way it wants to run.
So then, what you're saying essentially is that excess body fat will create a slower metabolism. The question then is, what is causing us to gain the weight, and what do you mean by metabolism exactly? Because I think people have different conceptions of what that means, and I think there's like scientific definitions and there's the common sort of understanding of it, which are a little bit different.
Yeah, no. Listen, and by the way, this term metabolism is a term that everyone thinks they understand, even doctors, right? So, like you and I, when we sit over coffee or lunch and we talk about metabolism, like we're busting out, the standard accepted scientific definition of the net sum of all the chemical reactions in the body, et cetera, et cetera. But I think maybe a different and a more contemporary way that people can relate to. So everyone has a car, right? And in a car, you just assume as you're driving your car that it will actually take the energy to power up the engine so you can get from point to point, right? That's what we do, and that's frankly what our metabolism is. It's the process by which our body drives our engine in our body, gives it energy to go around. We don't normally think about it, right? Just like you don't think about the energy in a car, you're just going about your way. Now, the analogy of the car is really useful to think about because when you're driving in a car, you do keep your eye on the fuel gauge. And when the fuel gauge runs low, what do? You pull over to the filling station, take out the pump, the nozzle, put it into the tank, and you press it, you fill up the tank, goes click, no more gas comes out, and you drive off, okay? Now, same deal in our body. When our body uses fuel, our fuel in our body for energy to drive the engine of our body comes from our food. Our food gives us our fuel, right? So we don't have a fuel gauge in the same way that a car does, but our brain senses it and our organs sense it so that when our fuel gauge runs low, we don't pull over to the filling station. We pull over to the dinner table or to the refrigerator.
7-Eleven.
Hopefully not to the 7-Elevens.
Yeah.
But the idea is that we pull over to fuel up. All right. Now, when we eat food, it's kind of like going to the filling station. And I want to first give this example. Imagine if you're filling up your tank in your car and the gas tank filled up, but that at the end it doesn't click when the tank is full. You know what would happen is that the tank would fill it would overflow. The gas would come down the side of the car, around your tires, pool around your feet, and you'd be standing in a dangerous, toxic, flammable mess. All right. And what would happen is you have to step away and wait for the air to blow it off, evaporate it. But our body isn't quite as cleverly designed. We don't have a clicker that's an off switch per se. So we can sit, pull it over to our filling station to fill up on food as our fuel, but we can eat and fill up and fill up and fill up and not stop. And so one thing, when we don't stop, we are literally overloading our fuel tank. So let's talk about the fuel tank for a second. All right. We need that energy from our food. Let's call it calories, but I don't want people to count calories or think about calories in and calories out. When you say the word calories, people kind of go in a certain direction. So I just want to talk about fuel. So basically what happens is that when you're putting food in your mouth, your pancreas makes insulin. Insulin is elevated, and basically it helps us draw the energy into our cells so we're able to operate. If you've got extra fuel, what happens is your body takes that extra fuel and it slows it up into fat cells. Now, we are born with fat cells that formed in our mom's womb, and they formed not to make us look bloated, but our fat cells at birth basically were our fuel cells preparing for later on when we needed to store energy. Now, a fat cell can actually blow up when you store it with fuel by about 100 times in size. But when that thing's filled up and you eat more food, your body has to fill up another fat cell and yet another fat cell. The more you eat, the more fat cells have to be filled up to 100 times their size. And when you run out of fat to fill up, you need a more fuel tank. Your fat cell goes to stem cells to make a new fat cell and fill that up as well.
That's terrible.
That's like going to the gas station and just loading up jerry cans of gas and stuffing your pickup truck with them and piling it high, right? And so what happens is that we can easily overeat and gain body fat and therefore gain weight just for that reason. Now, so that's one explanation for the body fat. Now, the other issue with regard to that, back to the car analogy, is the quality of the fuel we put in our car matters a lot. We want to put the highest quality gas into our gas tank in order to be able to run our car as long as we can. And if you basically put some crappy gas, low octane gas into your car once in a while, no biggie, the engine's going to run. You won't be, but if you did it for a whole lifetime of the car, it's not going to run as long or as well. Same deal with our metabolism over the course of our lifespan. If we put high quality fuel in, nutrient dense foods like plant-based foods, high quality sources of protein, we are actually taking care of our engine. And of course you don't want to eat too much. And so, but if you put low quality fuel, ultra processed foods, all those artificial preservatives and flavorings and colorings, what we're doing over time is we're poisoning our engine, including our metabolism.
Wow. So basically what you're saying is that this fat just kind of accumulates and then it slows our metabolism, and it's kind of a vicious cycle.
Yeah.
So, but you also said we shouldn't be so afraid of fat in a way that isn't necessarily the villain we thought it's supposed to be. So what's true about that paradox that you're highlighting in your book?
It's actually not a paradox. It's really about balance and homeostasis, like so many other things in the human body. So I like to tell people that when your mom's sperm met your dad's egg, when your dad's sperm met your mom's egg in the womb, and you were just a ball of cells starting to form your future body, the first tissue gets laid down is your circulation. And that's what I study, angiogenesis, because every organ needs blood supply. A second tissue that gets laid down is your nervous system, because every organ needs the ability to have the wiring to get instructions through this nerves to do something. All right. The third tissue that gets laid down are little fat cells. They're called adipocytes. And the interesting thing, Mark, about where these form, they form around blood vessels. The first fat is laid down like bubble wrap, like a layer of bubble wrap around blood vessels. And the reason why is preparing for later in life, when you're eating food, the energy, the fuel from your food has to be stored, and it's best to put your fuel tank right where the fuel is coming in by your blood vessels. So we're actually born with our body fat long before we had a face that we could stuff with food. So we got to ask that question. Why do we have body fat? And by the way, is it always harmful? Answer is no, because if you take a look at, fast forward 9 months, newborn baby, right? Makes everyone smile. You want to actually, you want to pinch its chubby cheeks. Healthy babies are chubby, tubby. They've got big cheeks, big tummies. Their arms and legs look like those balloons that a circus clown makes the little poodles out of. They're big, right? Okay, and so fat actually in a baby is healthy. In fact, if you saw a baby that had chiseled cheeks like a runway model, long thin arms and long thighs, you'd be freaked out. You'd say there's something seriously wrong with that baby, right?
Yeah, it would look very sick. You want those chubby, fat cheeks.
And so that's one of the things that I think is so important for people to understand, is that fat is not our enemy. We had our body fat for a long time, and so what are the roles of body fat as we grow up, right? I mean, basically, I will put a little footnote to say, every little boys and girls all look the same, but as we go through puberty, it's really our body fat that kind of shapes us. So, the female form, that classic form, actually you get a little skinnier in the waist, less subcutaneous fat. Guys actually get a little bit bigger. They get a little more visceral fat. Hips get bigger, breasts, but all those, it's the fat reshaping it. So if you were to think about the human body being made by Michelangelo, back to that statue of David, body fat plays a big role in that. However, let's talk about for any person, not just sort of like the idealistic figure. Here's the 4 things that body fat does. Number 1, it's a cushion. Okay, and if we didn't have body fat, if you tripped on a carpet and you fell on the ground, your organs could split open. So thank goodness we have a little bit of cushion.
Sounds terrible,
right? Number 2, what is it? It's a fuel tank, like we talked about. You need to actually have your fuel. So your body fat is critical for your metabolism. It's part of our metabolism. It's the fuel tank that stores our food. The third thing that body fat does is quite remarkable. It's an endocrine organ. In fact, it's the biggest endocrine organ in the body. Endocrine organs like your thyroid, your adrenal glands, like your glands, your ovaries and your testicles. To think that body fat's an actual organ is a kind of stunning thing to think about.
Just like your muscles are an organ, right?
That's right. So here's the endocrine hormonal function of healthy body fat. All right. This is like, to keep you alive, you have to do this. There's about 15 organs that, at least 15 organs that we now know that body fat as an organ makes. Healthy body fat. One of them is called leptin. Okay. Now, leptin, people think about it as a satiety hormone. I prefer to explain it as a volume switch. When the leptin is elevated, you don't feel so hungry. When the volume is down, you feel a little hungrier. So it's not a light switch to go up and down. You turn it on, the lights and off. It actually goes up and down, like so much of the body. And like hormones go, they're kind of a feedback loop. So a little bit higher, a little bit lower. That's leptin. Second, and by the way, when you're hungry, what do? You pull over to the filling station to fill up. So very important for our metabolism. Second, there's a hormone called adiponectin. And if you and I saw a patient and ordered a vial blood, standard vial blood, to be sent to the hospital lab to measure all the hormones in the body, a hormonal panel. There'd be the thyroid, there'd be the cortisol, all the other hormones, testosterone. There'd be one hormone, adiponectin, made by healthy body fat that is 1,000 times higher in your circulation than any other organ, any other hormone. And the reason it's so high is that adiponectin is part of your metabolism. It collaborates with insulin to make your energy extraction from your blood, from your food and your fuel back into your cells more efficient. And so when you have a lot of adiponectin, you're capable of getting that energy in when you're eating, which is so important. And then there's another, and if adiponectin is kind of the gas pedal for efficiency, a third hormone called resistin is the brake. Adiponectin draws in more energy, not so fast. Resistant goes there. So again, balance. Think about driving on a highway. You're on a 4-lane highway. Every now and then you got to get into the fast lane. Adiponectin goes on, but then there's a car coming up, so you got to slow it down. These hormones are naturally functioning along with leptin in order to be able to tell us to go to the filling station and how we fuel up and how fast we actually fuel up. This is normal. That's a third role of fat. And the fourth role of fat, which perhaps is one of the most surprising, and you hear about this in the fitness world, but is that your fat can also be a space heater. And by space heater, I mean that there's a special kind of fat called brown fat that will ignite and fire up by drawing down fuel. Now, this is kind of like the gas burner on your stovetop, right? So what do? You hit a striker and it goes whoosh, and you wind up having a flame. That's like brown fat, okay? And what it does, in order to get that flame, it's drawing the energy from your other fat cells. So it's brown fat, good fat, drawing on the energy to burn down bad fat. So I have a little demo here for your guys. And I show it, is that think about brown fat like this. It's like a torch. You turn it on, this is brown fat. It is burning down fuel. Where's this fuel coming from? It's drawing this fuel when it's turned on from your white fat. And so this is how you can actually use one type of fat to fight another type of fat. So those 4 functions of body fat really help us reconceptualize, like, don't fear it, but tame it.
So is there a way to activate brown fat with food? Because we know how to activate it, for example, cold therapy, because often cold plunges increase metabolism, improve insulin sensitivity, and they've been shown to actually help speed up your metabolism and burn white fat, which is the kind you don't want. So can you take us down that road if there's anything that we can do other than like lay in a 40-degree cold plunge to activate our brown fat?
Yeah, well, look, I mean, this, I don't know, are you...
Although, by the way, I think people should do that, but yeah, it's not everybody's cup of tea.
What's interesting is how brown fat was discovered, because it was discovered in humans. We've known for hundreds of years that there's a little bit of brown fat in animals that hibernate, which means that they're sleeping in cold temperatures and they need warmth. And so the brown fat in hibernating animals actually fires up, and it provides their heat by drawing down the fat that they've stored when they're actually getting ready for the winter, right? So, okay. So in humans, brown fat was actually discovered in a Boston hospital with a female patient who had a tumor in her chest. And they had a PET scan of this woman, and PET scans look at metabolism, right? We're talking about metabolism. And guess what? This little tumor in her chest lit up like a Christmas tree. It was really metabolically active. So they didn't know what it was, but when they biopsied the tumor and they looked at it under the microscope, it turned out to be brown fat. Brown fat was thought to be in children for a little bit behind their shoulder blades. Most people thought that's not in adults, but here was with an adult with brown fat. And so what the researchers did at this Boston hospital, Ronald Kahn, they went back and they said maybe other PET scans are showing brown fat and we just haven't been looking for it. So he went back and looked at 1,000 PET scans of adults that were getting scans for lots of different reasons. And he went to look for the brown fat signature. And guess what? He found it in about half the people. And so he's like, well, that's interesting. It seems to be present. But what he found out is that it became much more noticeable when the people who are getting these PET scans were getting their scan in the winter in Boston when it's cold. So getting a PET scan in the summer, the brown fat doesn't light up as much, but cold temperature definitely fires it up. And it's all over adults. And so basically they were able to characterize, and this is a big program at the National Institutes of Health now, at the NIH, they're actually figuring out where human brown fat is. They've profiled it. And actually, the researchers actually gave me permission to publish the photographs in my book, Eat to Beat Your Diet, some of the first pictures ever of brown fat. And
really?
So lumpy, bumpy, white fat, which is the harmful fat, is lumpy, bumpy. It's the jiggly stuff under your arm, under your chin. It's the muffin top, okay? And the visceral fat, by the way, also lumpy, bumpy, but you can't see it because it's inside the tube of your body. Brown fat isn't lumpy, bumpy. It is wafer thin. It's paper thin. And it's not near the skin. It's close to the bone. And where is it in the body? And this is what's really cool about the imaging studies. Yeah. It's plastered around the side of your neck.
Yeah.
It's behind your breastbone. It's under your arms and a little bit in your belly. Okay.
And behind your back and your shoulder blades?
A little bit behind your back and your shoulder blades, but a lot under your arm, kind of like a bra. Okay. And a lot under exactly. So think about it, right? This is how we stay warm in the winter, right? So what's really cool is that as they've been teasing out the mechanisms of how cold actually stimulates brown fat, turns it on, it turns out it's the same pathways that foods can turn on the same pathways. So basically, here it goes.
Yeah,
You go
let's
cold
talk about
temperature,
that.
your brain releases norepinephrine, which is kind of a stress hormone. Really, when you get into that cold bath, right? Like you go, whoa,
Yeah,
right?
exactly.
Jump
Right.
into the ocean. You go to the beach and the water's cold. Whoa, and that whoa is tells your brain to go release stress hormones. And what happens is that the stress hormones run down the nerves to the rest of your body. But when they get to your brown fat, some of the nerves go to your brown fat. It fires them up, and it makes a lot of sense because you're trying to warm up for it. So we now know that norepinephrine will actually bind to a receptor in brown fat called the beta-3 adrenergic receptor. This is a very well-known switch on our body, and anything that can trigger that switch, like hot chili peppers, like mushrooms, like sulforaphanes and broccoli, can trip that switch, the beta-3 adrenergic receptor. Then what actually happens is that there's a domino effect inside our brown fat, that wafer thin fat. The beta-3 adrenergic receptor, when it fires off, when that light switch is turned on, it sends another signal, like it's like dominoes. The next domino it turns on is something called UCP1, uncoupling protein 1. So the hormone triggers off the switch called beta-3 adrenergic, which then triggers off another switch called UCP1. UCP1, by the way, is on top of the mitochondria. And I like to actually, which is in brown fat. And I like to tell people, and I'm sure maybe you had your own word for this, but when I was memorizing all the stuff in medical school, mitochondria, which is a fuel cell, an energy cell inside, like a battery inside all of your cells, I called it the mitochondria. Because it actually is like a fuel cell, like a nuclear power plant. And when that adrenergic receptor trips that light switch at the UCP1 on the mitochondria, it fires them up. And guess what? Mitochondria has a lot of iron in it, the element iron, the metal iron. And a lot of iron, by the way, packed together is like rusty nails. It's colored brown. Iron tends to oxidize as brown. That's why brown fat is brown.
Wow.
Because it's got so much fuel cells with so much iron, it looks brown. I'm a scientist. I ask the whys, right? Like, why is brown fat brown?
That's a good question. I never thought of that.
That's the answer, right? Okay, so it turns out that anything that turns on that beta-3 adrenergic switch, cold weather can do it. There's a bladder spasm medicine called mirabegron that also specifically designed to hit that switch on your bladder. But guess what? Researchers have actually shown it'll hit that switch on your fat cells, fire up your brown fat as well.
Is that why you have to pee when you're cold?
Well, but they did that experiment to show this mechanism at really high doses. So I don't recommend anybody you try to use mirabegron to actually fire up their brown fat. But it turns out foods like chili peppers, like avocado, like walnuts, like capers, are all capable of firing off this switch. And so what I do in my book is, in the research that went into this, is like there's 150 foods that have been discovered, along with the doses of how much it takes to fire off your brown fat.
Really? Like what foods?
One thing is sulforaphanes, right? So sulforaphane-containing foods like brassica, broccoli, bok choy, cauliflower, that entire Swiss chard, all of those substances containing plant-based foods containing sulforaphanes will fire up your brown fat. So will the beta-glucan in mushrooms, white button mushrooms, shiitake, enoki, maitake. Right? I mean, some of the.
Well, I feel good about my dinner last night because I had gailan and shiitake mushrooms.
You were firing up your brown fat, right?
Okay.
So this is, and by the way, as I went through the entire catalog, and I wrote my whole section about food in this book, imagining for my reader that I was taking them through the grocery store and the shopping cart as if they were a kid. Like when you were a kid, you hopped in your mom's shopping cart and she was pushing you along. Except this time, what I'm doing is, as we're going through the different sections of the grocery store, I'm telling you what to pull out that will activate your metabolism at burning body fat and put it into your cart. Produce section, the forbidden middle aisles, the seafood section, the beverage section. It literally is it's like a tour of your grocery store to what to shop. like a shopping list for metabolism.
Yeah. So shiitake mushrooms and mushrooms, the broccoli family. What else activates brown fat?
Okay, so one of my favorites.
Because this is important, because what you're saying essentially is that we don't activate our brown fat enough because we don't have cold exposure. We don't eat certain foods that are meant to do it. And it undermines our metabolism. And a way to speed up your metabolism is actually to activate brown fat. So
Exactly.
so that's why this is so important for people to listen to.
And by the way, let's do this again. Activating your brown fat with food is like turning on your burner, okay? And that you're burning down fuel.
That's quite a lighter you got there, William, Dr. William.
Like
I don't know. Are you sure you're not a little pyromaniac on the side there?
No, it's great for a fireplace. But it's a great illustration because people really understand that the strength of that flame has to come from someplace, and that's really the potential of our brown fat. So, what are some of the other foods besides, the greens, the leafy greens, the kales, the mushrooms, the onions, the red onions I talk about? I actually like to say, surprisingly, if you go into the middle aisle of the grocery store, remember we used to always lecture people to stop the perimeter. That's where obviously there's a lot of good stuff, but it turns out there's a lot of good stuff in the middle aisles. It's just buried with all the junk.
Like sardine cans and olive oil.
Exactly.
Right?
And dried apples and capers in jars or in bags, lentils, prunes, tree nuts, tomato pastes. All these kinds of foods actually have been shown to activate brown fat in the lab. They actually activate metabolic stuff. So all the foods that I talk about in the book have human evidence. So I explain the lab, but then I actually show the human research that actually shows that, meaningfully, when you eat these foods over time, like 3/4 of a cup of dried apples, like dried apple chips, actually will lead you to lose almost an inch of your waist circumference over the course of a month. All right. And this is like controlled studies with placebos, not requiring people to cut their calories or go on a special exercise.
If we eat less and exercise more, we're going to lose weight. In fact, that's what all of our dietary recommendations are about. That's what you'll hear from your doctor, from your nutritionist, from all the professional societies like the Academy of Nutrition Dietetics, AMA, the ADA, American Diabetic Association. Pretty much, you'll also hear from obviously all the food industry experts, because if it's all about calories, then 100 calories of soda are the same as 100 calories of almonds. So it's just about the calories. And if you eat less and exercise more, you're going to lose weight. And we were just chit-chatting about the shift in the paradigm. And this morning I was reading this article that our friend Dariush Mazafarian wrote called Obesity, an Unexplained Epidemic. And it's obviously you can't read it on the Zoom, but we're going to put it in the show notes. It's available free. And it really challenges this notion that it's all about calories, because in the article, he shares data. This is hard data from large government surveys that, in fact, since 2000, last 22 years, we have eaten less and we've exercised more. And yet we're getting more and more and more overweight and more diabetic. So how do you sync that up if it's not all about calories, if it's not all about energy balance, I'm not all about eating less and exercise more? What do you think about this, William? And how have you come to shift your thinking around the idea about calories?
Yeah, I think you just set that up perfectly, Mark, which is that we've had this notion for decades. And in fact, I'll actually throw the stone even further back in time, back to like the 15th century, 16th century, when, the first people to even come up with the measurement of metabolism, they created the Sanctoris Sanctorum, that this guy, he created a chair that he could sit in with a dinner table in front of him, and it was suspended by a chain, and he could weigh what he weighed and how much food he ate, and he actually collected his urine and his feces, and he would compare it to what he was actually eating, right? So there are these great wooden engravings going back to medieval times with this like calories in and poop and excrement out, okay? And it's not false. It's basically, it's a good basic principle, but where we are now is we are light years ahead in our refined understanding of not just calories, but how the body processes what you put into it. It's kind of like fuel. You got a nice car. If you're actually putting good quality engine oil in it, good quality calories in the case of your body, your car is going to drive a little bit longer. It's going to perform better. Okay. It's going to be happier, and you're going to be happier with it for a longer period of time. If you take really crappy engine oil, or look at your fuel tank and you put the cheapest quality fuel into the best car that you want to actually keep for a long time, it'll drive for a little while, but the toll will be taken. And I think that's really one of the things that this research.
Wait, William, that reminds me of a story. When I was in residency, I lent one of my fellow residents my car, and it was a diesel car.
Oh no!
And he put gasoline in it. It was the worst thing. That's kind of what we're doing to ourselves. We really are,
Yeah. Well, listen, I mean, just like your the friend who you lent the car to, and you have to be informed about what you're putting inside your chassis, your fuel tank. And I think that's really the biggest misconception, that it's simply a number, like a calculator.
Yeah.
Calories in, calories out. If you exercise, if you eat less, you're going to be all set. And as a matter of fact, the quality of the calories makes a huge amount of difference. You could have the same number of calories in a can of soda, okay, as you could actually have in a plate of fruit. And they would obviously be radically different because of the effect of the micronutrients on those aspects of your body.
Yeah, I'll tell you a funny story. So I was on the Today Show years ago, and it was, God, I don't even know, like maybe, I don't even know, 2006 or 7.
Okay.
And I was on about one of my books, and after I was chatting with the producer, and I said, I have a great idea for a segment. And she's like, what is it? I said, well, why don't we do a segment on 100 calorie? Because at the time, 100 calorie snack packs were like 100 calorie Oreos, 100 calorie M&Ms, 100 calorie whatever. I'm like, let's do a segment of like 100 calories and talk about 100 calories of blueberries versus 100 calories of like Oreo cookies. Right. And I had a whole table full of this stuff. And somehow it slipped under the radar, and they were like, yes. And I got on. Yeah. And all of a sudden the host, and they get kind of briefed a little bit beforehand, realized what was happening. And the advertising for all the television is either drugs or junk food. Right. If you look at television advertising things, and it was threatening all of their advertising partners. And so she tried to redirect the whole thing, because I was like, listen, here's how 100 calories of blueberries affect your body, and here's how 100 calories of soda affect your body. And then I got kind of excommunicated from the Today Show for years and years.
Well, but like, I think that these points that we're making are so fundamental. And I would say anybody watching or listening to this is going to recognize that, it's almost like a truth that if you just count your calories and you go to the gym, you're going to actually lose weight. You're going to be fine. And it's clearly not the case. Mm-mm. What's actually happening? I mean, if you take a look at what our body does to maintain healthy function. Let's talk about function before we get into the depth of metabolism. Yeah. Look, we've got our circulation fuels our muscle, brings blood and oxygen to our muscles. Our immune system controls inflammation and allows us to actually combat all the attackers that are coming to us from the outside and also the inside of our body. We're exposed to environmental pressures like ultraviolet radiation and radon from our feet. It's amazing that we're actually not sick more often, but fortunately, all of those myriad of environmental influences are defended against by our body. And so when we feed ourselves, it's no different than walking into a cloud of something. If you walk into a cloud of synthetic chemical junk, and you're breathing it in, you know that you're going to come out of it feeling sick. I mean, that's the 9/11 effect, right? This gigantic pile of stuff put up dust everywhere, and people got sick. Yeah. There's no surprise. And I think that what we're now realizing, I think this is a wake-up call that the public is actually having, and the scientific community is digging into it now, is that when we actually feed ourselves good quality calories, and we actually do the things that we're supposed to do, which is stay physically active. You don't need to work out. You need to be active and get good quality sleep and actually lower your stress. All of these things converge to really help our metabolism actually right-size itself.
Yeah, it's so true. Your book, Eat to Beat Disease, was so important because it really took the macro framework of what Hippocrates said 5,000 years ago, which is let food be thy medicine and medicine be thy food, and made it very granular, very scientific, and very specific, and showed exactly how different compounds in different foods, and I'm talking about actual food, not processed food,
Right.
affect your body and regulate every single biological process. And so that's such an important idea that food isn't just calories, it's actually information, that it's medicine, that there's instructions or code that regulates everything that goes on is so important. Now, I can imagine that there might be some physicists out there listening to this and saying, Dr. Hyman, Dr. Lee, you guys are smart and all that, but you're not physicists. You don't get this basic thing called the first law of thermodynamics. Well, guess what? We had to take physics going into medical school, and I know what that law is. And that law, if you read it really carefully, says that energy is conserved in a system, in a closed system. So yes, if you take 1,000 calories of soda and 1,000 calories of broccoli and you put them in a lab, they will actually release exactly the same amount of energy. And all a calorie is the amount of energy required to raise the temperature of 1 liter of water 1 degree centigrade. That's it. Okay. But if you take, for example, another example, if you take feathers and lead and you drop them in a vacuum, they drop at exactly the same rate because there's no air. If you drop them off a bridge, the lead goes boom and the feathers kind of float down in the air. Well, it's the same thing when you eat. Your body has something called metabolism. It has the microbiome. It has an immune system. It has hormones. It has neurotransmitters. It has peptides and messenger molecules, all of which are being influenced not just by the caloric intake of what you're eating, but by the informational quality of what you're eating. And so it has profoundly different effects on everything, and it's not the same. So yes, the first law of thermodynamics is true. I'm not disputing that, but it doesn't hold in a system called the body.
And because our body is actually made of different systems that are interconnected, and it's not just a system in a snapshot of time, but over a period of time. So it's not a Xerox. It's not like a photocopy. It actually, our body is shifting over time as we age, and there are all these little gears and parts are all moving and responding to that information. So here's the thing that, listen, I'm an internal medicine doc like you. I'm a vascular biologist, and I've been involved with biotech development. So for me, I've always been curious on the mechanisms. What do we understand about a molecular or cellular process that drives a disease? And if we understand that, could we apply the science to come up with a solution? And that's really how immunotherapy and anti-angiogenic therapy and all these growth factor therapies, this is modern medicine at its best from a technology perspective. However, what really drew me into the nutrition world was I realized that, when we're diving after disease, including obesity, by the way, we're already kind of looking at we're trying to figure out what causes the hurricane while we're in the eye of the storm. Everything is blowing around us. The roofs are coming off, ducking for cover. And so one of the things that I think is so fascinating to me as a scientist, as a doctor, is really going back to take a look at, well, what happens before you're sick? Like, what's the basic function of the body like before we're trashed, at any age? And so this is where a profound study was published in 2021 in the journal Science, one of the most credible scientific journals, by a guy named Herman Ponzer, who's a professor at Duke University. He worked with colleagues from 19 other countries to look at 6,000 people and ask what was their metabolism like. And so, the onesies and twosies and the threesies studies that have been done on metabolism, or people that are doing sports drinks or athletes doing research studies, that's one thing. But what they did is they took a look at, it's amazing. They took a look at people that were just a few days old to 95 years old. They applied the exact same measurement system, which uses a form of water that has an atom that you can actually measure in a room. So talk about a closed system. So you put these people into a closed system and you give them this cocktail to drink, and it's just water.
It's like radioactive water, kind of, but not really.
Yeah, exactly. So like people then become Spider-Man. All right. But what wound up happening is that they could actually measure from their breath and their urine how their body was using metabolism. And what they found was, of course, everybody's metabolism was all over the place. So information, right? So put information in, they're eating and drinking, information out, they're measuring it, looks like a mess, except one of the things that they did is they developed, back to the physicists, they used mathematics to kind of correct for age, size, sex, and this is really kind of the mic drop here, they corrected for body fat. So what they realized is that everyone's going to have a different level of body fat from the time they're a baby to their time they're in their 90s across the age span. And when they did that, this chaotic data set suddenly clarified itself into 4 phases of human metabolism as we age from a few days old until we're in our 90s. And that really changed my mind when I saw that data to go, this is like a eureka moment. That humans all are hardwired, and it makes total sense to go through the same stages of cellular metabolism as we age. And so there's 4 phases. 0 to 1 is one phase. So when you're born, we're corrected for body size. We have the same pace of metabolism as our moms did. That makes sense. We were synced with our mom's metabolism, corrected for size. But from 0 to 1, our metabolism soars to about 50% of higher than what we're going to have when we're an adult. And that's why neonatal nutrition, what we feed our babies in their first year of life, is so profound. All those cells are taking in those calories, the nutrients, breastfeeding, everything counts in the first year of life. So from the get-go, the fuel that we're giving our bodies actually can make a huge difference going downstream. From 1 year old down to 20, our metabolism actually starts to go down to adult levels. And so when you're a teenager and you're seeing teens eat 2 or 3 dinners and they're spring up a tree, right? What do we always say? Like, oh man, our kids are like sprouting like trees, their metabolism's going crazy. Actually, the metabolism is going down, heading down towards adult levels. Surprise, right? And then from 20 to 60, that's during college age, your first job, your marriage, your marriage, if you get divorced, your menopause, all those kinds of things, right? Where people
what does divorce do to your metabolism?
Well, it's stress. It's stress, right? So menopause, all those kinds of things. Actually, it's a straight line of how our body's programmed. And only at 60 years old, in our 6th decade, does our metabolism start to decline very, very slowly, so that by the time we're 90, our metabolism at 90 years old is 75% what it was when we were 60. So as adults.
But that's not inevitable, right? I mean, that can be modified.
So that's a key thing. You can modify it up or you can modify it down.
Because I noticed, my metabolism is faster now at almost 63 than it was when I was 40. And I actually have to work to keep the weight on because I've sped up my metabolism by knowing what to do to activate the right pathways to do what I wanted to do.
Exactly. And so this is the perfect segue into thinking about if there's a set pattern that humans are programmed to be able to have over the course of the lifetime in terms of this pattern that we call metabolism. And this is, again, corrected for age, sex, size, and body fat. Now, let's start to look at what good things you can do to raise your metabolism, right? So what are the things? Your microbiome, your epigenetics, your circulation, your inflammation. There's all kinds of things you can do to support and elevate to get to that next level of metabolism. But the same token, there's a lot of things. Put that wrong fuel into the engine, and now you squash the human metabolism as well. This is actually a eureka because now we've taken it way far away from calories in, calorie out. What we're saying is that the quality matters, the systems and how we live our lifestyle matters. And so for someone like you, Mark, I mean, and look, you and I have known each other pretty well. You're somebody who practices what you preach, and all of these things that you do, choosing the right foods, getting the right exercise, lowering your stress, managing inflammation, getting the right sleep, all of these things actually help to elevate and get your metabolism above what the average human should have.
Amazing. All right. So everybody talks about metabolism, but what the heck is metabolism? We have a slow metabolism, fast metabolism. What does metabolism mean? And what do you mean when you refer to metabolism?
Yeah, well, like I think we have to take a step back to essentially say that metabolism is really the process that our cells use to extract energy from food, if we're feeding ourselves, and from within our body to be able to power up and fuel all of the functions, from the molecular to the cellular to the organ to the organismic level. That's basically what metabolism actually is. And we don't think about it that way, but I think science is telling us that there's all these layers to peel back to understand how the engine runs. So, if anybody who's actually sat in a plane, right? You get your boarding pass, you get onto the plane, you buckle your seatbelt, you settle back for the flight. It's kind of like getting into a plane is kind of like trying to understand metabolism. It seems kind of easy. You can settle down into the seat, and just enjoy the ride. But in fact, there's a lot going on, from the cockpit to the engines, to the fuel tanks, to the weight of the passengers and the weight of the luggage, to the delays, to the air traffic control. And so that analogy really tells us that somebody needs to be in charge of understanding this. And I think that's where folks like you and I, Mark, are really trying to play our role in digging into what the science is actually showing and connecting the dots with what everybody already understands. And whenever there's a misconception, we got to try to clear that up.
Yeah, and then, I would just sort of add to that. I mean, some people define metabolism as a sum total of all chemical reactions going on in your body. As a whole field of metabolomics, which we can now measure thousands and thousands of things going on in your body at the same time. But when I think of it as a doctor, I'm thinking about how do I optimize my patient's health, and how do I work with their metabolism to make it work better so they can get the energy they need to live lives, so they can optimize all their biological functions, how they can use food as medicine. And when I've come to realize there's so many things that influence it that are far beyond calories and energy. So one, you talked about the quality of the calories. There's the macronutrients, which is protein, fat, and carbohydrate. And what's the quality of the protein? Like if you eat steak from a grass-fed or a kangaroo, let's say a wild kangaroo versus a feedlot cow, very different effects on your inflammation and metabolism. Right. If you eat a carbohydrate from, refined high fructose corn syrup or from asparagus, very different. If you eat a fat from Crisco or omega-3 fats, very different, calorie for calorie. Everybody understands that. It doesn't take rocket science. So there's the macronutrients. There's a fiber also, which is very complicated in terms of how it affects the microbiome. There's the vitamins and minerals. And there's all these phytochemicals that you write about in your book, Eat to Beat Disease. And these phytochemicals turn out to have profound effects on all kinds of regulatory pathways that have to do with how we burn calories, how our mitochondria work, how our immune systems work, what happens to our microbiome. And then, of course, there's all the other things we have to deal with, like all the toxins that are around that affect our metabolism. They're called obesogens. They literally interfere with our metabolism. Actually, I was in the White House. You'd be interested, I went to Washington. I was in the White House this week and was talking to the head of the White House Conference on Hunger, Food, Nutrition. And she said, yeah, what do you think about this whole thing about toxins and metabolism? I'm like, yeah, it's a thing. I wrote an article about it like 15 years ago, and it's real. And I see it in my patients. So there's so many different factors that influence the system, because our body's not a closed system. And of course, there's effects of stress and our beliefs and epigenetics. And so all these, it sounds like super complex. And there's hormonal effects. How do our hormones affect it? How do our sex hormones affect it? Our insulin, our cortisol, all these things that happen. So in a sense, it's kind of complicated, but when it comes down to it, the to-dos are actually pretty straightforward on the what to do's. So let's
before we dive into the do's, I also want to maybe just to bring it home to people who are listening that are not really into the learning all about all the different aspects of the science and keeping up with all the very important things you just said. Here's what boils down to. Most people realize that their body's metabolism is connected to their weight, right? That's one of even a kid in grade school learns that pretty early on. And here's one of the things that I think, for metabolism, it's so complicated what we're learning. Maybe it's simpler to help people understand what we're learning is not correct. Like, what are the myths of metabolism? One of the myths we just talked about is the fact that a calorie is a calorie. Just count your calories and exercise, and you're going to be all set. That's not true, obviously. The second thing, and the quality obviously matters. The second thing that's really interesting is that, how many people have you heard say, my sister or my sibling was really lucky because he or she was born with a fast metabolism, and look how skinny he or she is, right? And then, of course, then the other line is that, well, look, I wasn't so lucky. I was born with a bad metabolism, and that's why I have so much struggle with my weight. I can't tell you the number of patients I've actually heard from that. And actually, honestly, when I was in medical school, I drank that Kool-Aid too, because, for sure. Right, that's the stuff that we learned. It's almost, and yet you don't really find that in a textbook. That's just the populist belief. Here's what the science is actually showing.
Yeah.
In fact, our body fat is our most important gland, endocrine organ in our body.
Yeah.
And most people don't realize this, but before you could stuff your face to get fat, your fat formed before you even had a face. So here's a sperm and egg meat, your ball of cells. Some of the first organs that form are your circulation and your nerves. They form this kind of like these lakes and these little tributaries. The third cell after blood vessel nerve that forms in your body is adipose cell. Your fat forms. And in fact, your fat forms before any other organ. So you got to ask yourself a question, which is what I'm doing now. Like, I'm diving deep into this stuff, really like a scientist trying to understand what's going on. This adipose tissue communicates with your circulation, communicates with your nerves, and is actually an endocrine hormonal organ. It produces at least 15 hormones that connect to your brain, to your stomach, to your immune system, all these other things. Adiponectin is one of them, that certain foods can make make more your fat. You want to feed your fat good stuff so it makes better hormones for you. Yeah. But fat, like any other tissue, has to be tamed. And so I think that's another kind of myth to be busted, is that fat, it must die. Wrong. Yeah. Fat keeps us alive. It's when it gets untamed.
But you want smart fat, not angry fat.
That's right.
Because, I think our friend David literally talks about how the way we have eaten with these refined carbohydrates and starches has created hungry fat. So our fat cells are very hungry. And he challenges the myth that overeating causes obesity. I mean, I don't think there's probably except a handful of people who understand the science who don't believe that overeating causes obesity. And what he says is it's the other way around. If you start to accumulate weight, it's the fat cells that make you hungry that cause overeating. So it's actually being obese that makes you overeat. Really a very different, and it also makes you exercise less, and the way it affects your body. So the question
it's a domino effect.
Yeah. So the question is, how do we then change our diet to address this? Because the predominant theory has been about energy balance, which is what we talked about, calories in, calories out. I wrote a lot about this in my book, Food Fix, because it was really a very political thing, and the Coca-Cola funded, to the tune of about $20 million aspects of this energy balance idea, and trying to get scientists to prove that it's all about calories in, calories out. And David has come up with a different framework called the carbohydrate insulin hypothesis. And this paper that was published by him and other leading scientists and heads of societies was called Competing Paradigms of Obesity Pathogenesis. It means, like, what are the different paradigms of why we gain weight? Energy balance versus carbohydrate insulin models. And what they say is it's like the quality of the calories has a profound effect on your hormones. Like, what happens to those fat cells? What hormones do they produce in response to different calories? So if you're eating starch and sugar, which is the predominant foundation of our modern diet, you're triggering all the wrong messages that literally slow your metabolism. So when you eat a bagel, you're slowing your metabolism down, which people don't realize. When you eat fat, and the right fat, you're speeding it up. And he did this crazy study, which you know of, where he took overweight people and he gave a crossover study, which is kind of the best kinds of experiment you can do, where you take the same people and feed them different diets in different time periods. So you're testing, sort of as integrity. Yeah. And he basically gave them, a high carbohydrate, but healthy, like low fat diet for a period of time, measured their metabolism, their metabolic rate, how many calories they burned, how many calories they ate. And then he gave them a high fat, good fat, but very low starch, sugar, carbohydrate diet. And he said the ones who are overweight and insulin resistant, they eating a high fat diet burn 400 calories more a day. Now, if you multiply that times 7, that's 2,800 calories in a week. To lose a pound, you need to burn an extra 3,500 calories. That's almost a pound of weight loss a week by eating the same amount of calories. So this is not some kind of hypothetical in a lab experiment with a bunch of rats or mice. This is with actual humans eating the right food in a controlled environment, which is, these are studies that are very expensive, very hard to do, like $12 million, which nobody wants to pay for because, who's going to pay for that kind of study? It's not a drug company, but there were some philanthropists who funded it. And it was just groundbreaking. So when you hear that, you're like, wait a minute, we need to rethink all this stuff about metabolism because our old ideas just don't work anymore.
Well, and I'll tell you, just jumping into there, that it even gets deeper than that when you look at those micronutrients, those bioactives that are present mostly in the foods that we already know are healthy, right? Whole plant-based foods, nuts and legumes, healthy oils. So the things that, like you and I have written and spoken about frequently, those natural chemicals, the lycopene, the quercetin, the hydroxytyrosols, they are now surfacing as players. These same natural chemicals that are found in healthy plant-based foods, whole foods, actually are players because they can help sensitize our cells to absorb energy. So they improve insulin sensitivity. They can also help us switch that bad fat, undesirable fat, hungry fat, into good fat, the brown fat that actually can crank up your energy burn, which is really cool. And also, by the way, certain bioactives can intercept stem cells. So our body has these fat stem cells to make more fat. Certain foods can intercept them and take these baby pre-fat cells called pre-adipocytes and make them stay there. It's like it's like a traffic cop, telling somebody to stay right, tell that car to stay right there. We can eat foods that can actually direct the traffic of fat, which I think is really remarkable.
Just adding foods to the diet will actually trigger these processes to burn down extra energy, burn away some of this fat, the extra energy, shrink your fat cells, and unleash your inner metabolism. And some of the most dramatic things, by the way, I think are like navy beans. Pre-cooked, ready-to-eat canned navy beans, cheap stuff, right? I mean, people care about how much food costs in the supermarket these days. And if you buy a can of, this is from the University of Toronto, they studied men eating a can of beans, three quarters of a cup of can of beans, 5 days a week. Okay, and compared
of any kind of beans or
of navy ready-to-eat navy beans, kind you would make, the kind you make bean soup or a stew out of. And it turns out that just a little under a cup, 3/4 of a cup, 5 days a week over the course of a month shrank their waist circumference by an inch. Now, waist circumference is a good surrogate of the amount of harmful body fat you have inside you, because the visceral fat is a dangerous fat. The subcutaneous fat is either beautiful or could make you not be so happy with your body shape. All right. But the visceral fat, which you can't see, is actually inside the cavity of your body. So it's like peanuts you would pack into a FedEx container, you're shipping light bulbs. You can pack a lot of peanuts in a thin box and tape it shut. The box still looks thin, but it could be bursting with pressure on the inside. And basically, visceral fat is something that whether you've got a big body or a small body, whether you're obviously overweight or whether you're skinny as a stick, you can still have too much body fat. By the way, here's an interesting little factoid. Where's one of the first places you gain visceral fat, extra body fat when you start gaining weight? Take a guess.
Assume your belly, but maybe you're going to be wrong.
Exactly.
I'm going to be wrong.
Yeah. Well, 90% of people think it's around the belly, and reason, understandably, because that's what you would see. I'm gaining weight. You look in the mirror, I'm seeing it around your belly, but actually that's not so. Turns out that the first place you start building body fat, especially the visceral fat, is in your tongue. Your tongue can get fat. So if you take a look at the anatomy of the tip of the tongue is the Cirque du Soleil acrobat. It's actually it's capable of doing all kinds of crazy acrobatics. The middle of your tongue is muscular. It is it is buff and full of muscle to be able to move food around your mouth. The back third of the tongue is normally marbled like a ribeye steak with fat. Okay. And a lot of people don't realize this, but when you start gaining extra fat, one of the first places that it starts to grow where it matters, the visceral fat grows in your tongue. You get more marbling in the back of your tongue.
Wow.
Now, this happens even in skinny people. And in fact, it was studied in Sweden. Young women, women who are middle-aged or younger, who are thin, actually, when they started to gain weight and they started to gain visceral fat, they found it was in their tongue. They started snoring. Their bed partners would say, wait a minute.
Oh, wow.
You started snoring. Now, why? Because when you're sleeping, you're relaxed. And when you're relaxed, your tongue's relaxed. Your fat tongue is relaxed. It blocks your airways. And guess what? You have sleep apnea. And so even thin people who have a lot of visceral fat, it's not just the diameter of the airway. We used to think it's like the tunnel getting narrower, but even your tongue can gain weight. So these are some of these really interesting facts about body fat that we never really even thought about.
Amazing.
Which is why we need to actually take actions, as you say, to eat foods. If you really want to fight body fat and raise your metabolism, you don't want to fear your food. You want to actually lean into it to look for delicious, healthy foods eaten at a modest volume and also eaten at the right time. So it's not just, it's obviously what you eat is important and how you eat is important, but when you eat can also make a difference.
How do people best lose weight and lose their body fat? And what is your sort of prescription in sort of the eat to beat diet?
Yeah.
Right?
Okay.
How do we take all this science and make it real for people?
Yeah. Well, look, I get asked this question all the time when people see me wherever, on the street or in a lecture hall. They basically say, Dr. Lee, what diet do you follow? Right? Because they're assuming we all follow a special diet or our own diet. And I answer very, very, very authentically, very sincerely. I'm not on a diet. I don't go on a diet. However, I do eat in a certain way. And the way that I eat, and I think people will relate to this, I call it Mediterranean style of eating. Mediterranean happens to reflect the ways that I like to eat, I enjoy eating, and reflects my own background. I'm Asian. I grew up eating Asian food. I lived in the Mediterranean, and I spent time in Italy and in Greece and elsewhere. And I lived Mediterranean. I lived and learned to love Mediterranean cuisine, especially traditional cuisine. And so I always, whenever I'm choosing a meal or ordering off a menu or going shopping in a grocery store or the farmer's market, I naturally gravitate towards recipes and ingredients from one of those genres, which, by the way, Mediterranean and Asian happen to be traditionally among the healthiest eating patterns on the planet.
Yeah. Well, right? The blue zones are in Okinawa and basically the Mediterranean places, right?
Exactly. Right. So I mean, you were just there seeing this in action, and so I call it Mediterranean style eating, and I think that I use that to inform what ingredients I pick, what catches my eye, how foods are prepared, and by the way, also Mediterranean and traditional Asian foods. These culinary traditions tend not to be ultra processed. They tend to use fresh, local, seasonal ingredients combined in really unique ways and flavored with herbs and spices and nuts and legumes and healthy oils like olive oil. So that's one approach I take, is sort of how do I, for anybody who's sort of confused, like, okay, well, what style of eating should I have?
What's Mediterranean? But Mediterranean can be anything. It can be like pasta and pizza, or it could be like, fresh fish and vegetables.
So that's really what I try to do, is I try to present people with a list of ingredients you can buy in my book, in the grocery store, in the produce section, in the middle aisle, whether you're going to the seafood counter or you're going to the farmer's market. You can find these ingredients and they taste delicious. And you have to, somebody who said, I haven't had broccoli or I don't like fish, you haven't had somebody prepare it for you in the right way.
That's my theory. I think the reason people don't like vegetables is they were prepared poorly. I remember, I was in the movie Fed Up, and I went down and this family who basically never ate vegetables, and and they all thought they tasted bad because mostly they came out of a can and were awful,
Right.
or overcooked or mushy.
I hope you whipped them up some.
I did, but this woman said she had a friend of hers make her asparagus on the grill, and she thought, oh my God, this is really good. And
exactly. And that's, by the way, where I think if you see an ingredient that can activate your brown fat and help your metabolism, and you don't know how to cook it, in this day and age, go onto Google, or if you're shopping for it, go onto Google, type the ingredient, type Mediterranean or Asian, and type recipe, and then search video, and somebody will come up to show you
for sure,
with passion how to do it. That's a great, simple way to learn how to cook these ingredients. But, it's not just ingredients. I mean, so basically, fruits and vegetables, nuts and legumes, all the usual cast of characters. And I try to identify specific ones. The middle aisle, dried fruits and dried fruits and dried mushrooms, dried chili peppers, dried beans, all great candidates as well. Capers, I really love. Seafood, I take people into the seafood section.
So why are capers so good?
Oh, okay. Do you know that in onions, okay, which are not related to capers, you go to the produce section, you see onions, they've got quercetin. Quercetin is a natural bioactive that activates your brown fat. It actually redirects your white fat. It causes beiging, so your white fat, harmful fat, starts to look a little bit more brown, starts to do the right thing, and also redirects the stem cells, so you make less white fat, more brown fat. But quercetin in an onion is found 66 times higher, okay, in a caper.
Oh, wow.
So it is.
I love capers.
I love capers too.
And by the way, for those of you listening, you've been checking in on my podcast, you heard me talk about quercetin for longevity. And it's one of the compounds that's super important that actually can help reverse biological age. So I think it's very, very key.
And where do you get quercetin? You get them in dry, rocky Mediterranean islands, and capers are actually flower buds that are picked before they turn and open up as flowers, and they're packed in salt, or they're packed in brine or a little vinegar, and you got to rinse off all that extra salt. But whatever you are eating that's savory, if you add some capers to it, anything, it'll make it taste so much better. Yeah, like if you haven't been exposed to capers, you got to try it. Capers from the island of Santorini, or capers from the Sicilian island of Pantelleria. Those are some of the most famous culinary capers that are out there. I like to cook. I mean, I know you do as well. But, I think that the other thing is really talk to somebody who really enjoys cooking about these ingredients, and you'll get excited about them as well. But the point is that you can go to the seafood section. Something I wanted to tell you that I discovered. So, when I was writing the book, some of the people advising me say, that Dr. Lee, that a lot of people don't like to eat seafood. So be careful writing, including fish in your book. And that made me want to really write about a whole chapter on seafood. I call it the daily catch. And the reason is this: if you've ever lived near the shore, if you've ever been to Asia or the Mediterranean, there is so much tasty seafood there. And, here, I think in most, like in America, most places go, salmon, the salmon or the chicken. I'll take the chicken, at the wedding or whatever. It turns out that, yes, oily fish are healthy because you get marine omega-3 fatty acids. But there was a study from Iceland that was quite surprising. They wanted to look at what the effect of omega-3 fatty acids were on body fat. And guess what? Turns on brown fat, helps you lose weight, burns away visceral fat so your waist size can shrink. And of course, they found it that eating salmon 3 times a week for 8 weeks will actually cause you to lose up to 15 pounds. All right. So that's a lot of weight. Yeah.
Wait.
Okay.
Wait. So you just said eating salmon a few
3
times a week can help you lose 15
over 8
pounds?
Weeks. Yeah. So basically, now this is the study where they actually did a little bit of caloric restriction to get it started, then added salmon to see if eating salmon would actually trigger faster weight loss. So that's a pretty good amount of weight loss. Now, omega-3s are in salmon, right? So oily fish. In fact, I can tell you there's 1,565 milligrams of omega-3, marine omega-3 fatty acids in a 5-ounce serving of salmon. Okay. But here's what's crazy. And I think this is what opened my eye. The same researchers studied what they thought was going to be a non-oily fish like cod. Cod's not considered an oily fish. Cod only has 284 milligrams, not 1,500 of omega-3 fatty acids. Pretty low. Guess what they found? People that ate cod 3 times a week lost 10 pounds over 8 weeks.
Wow.
3 times
Was it
a week.
because of what they were not eating, or was it because of the fish, you think?
Both, because when you basically when they lowered their calorie intake, that kick-started it. But when you compare cod with salmon, you lost 10 pounds with cod over 8 weeks. You lost 15 pounds, 30% more if you had salmon. But guess what? Cod has so much less of the omega-3s. All right. So we're just comparing two kinds of seafood here. So you don't need as much omega-3 as we thought. You don't have to eat mackerel and anchovies in order to get adequate omega-3s when it comes to your metabolism to fight fat. Something as low as cod with that amount of omega-3s will do it. So in my chapter, I convert in different seafoods that cod amount of omega-3s. You want 294 milligrams of omega-3s in a serving? Guess what that translates to medium-sized Gulf shrimp. Oh, you only need eat 4 Gulf shrimp to get as much you get in that serving of cod. How many oysters? You need to eat 8 oysters. You want mackerel, which is really oily? You only need 1 forkful of mackerel to get that amount as a cod. You don't even need that much mackerel. Open up a tin and just take 1 forkful when you're done.
That's amazing.
Halibut, another whitefish.
You can even plug your nose.
Halibut, which is, a very mild whitefish, right? Not oily. You only need to eat half a piece of halibut, half the size of a deck of cards in order to get the same amount of omega-3s as you get in cod. So what I do, I go through all kinds of spiny lobster, mitten crab, razor clams, stuff that I love to eat.
Yeah. I love razor clams.
I'm telling you, so you got to check out this chapter 8. It's called The Daily Catch. And I have a complete list with all the converted doses of how many you need to eat. Joe stone crab kind of thing, like a stone crab. How many claws would you need to have? It's all there. So look, eating for your metabolism and to fight body fat doesn't have to be a chore. Don't fear your food. Love your food. Look at all the stuff that comes from the Mediterranean and from Asia. Look at the recipes. You got to be careful, what you eat. But then, like the last part of it, by the way, of how I do this, just to share a practical way, besides what to eat and be careful not to overload your fuel tanks by overeating. There is really quite a profound aspect of metabolism, body fat, and fat burning when it comes to intermittent fasting. So everyone thinks that intermittent fasting is like modern trend, but it turns out that we're always intermittent fasting. When we're sleeping, we're not eating, we're fasting. When we get up in the morning, eat breakfast, we're breaking our fast, which is what's called breakfast. Now, remember I told you, right? Remember I told you when you actually eat food, your insulin rises in order to draw that energy to load into your cells. Our metabolism is hardwired so that when you're eating and your insulin's going up, our metabolism stays focused on loading up on fuel and not burning it, okay? When we're not eating, our insulin goes down, our metabolism switches gears like switching train tracks and basically says, all right, it's time to burn some of that fat stored in cells. And maybe you're burning the fat from dinner. Maybe you're burning the fat from yesterday. Maybe you're burning the fat from the holidays. But that's actually when you're sleeping, you're actually able to burn. That's the way our metabolism is hardwired. So here's what I do. I try to give my body as much time to naturally burn fat as possible. If I'm sleeping 8 hours a day from 11 o'clock to 7 o'clock, for example, all right, here's what I do. When I eat dinner the night before, if I eat dinner at 7 o'clock and I put the dishes away at 8, I don't eat anything after dinner. I stop. I close my eating window at 8 o'clock. No midnight snacking, no noshing. I don't raid the fridge. No extra slice of pie before I go to bed. Now, guess what? I put the dishes away at 8 o'clock. I go to bed at 11. I've gained 3 extra hours of fat burning, metabolism, grooming. When I get up in the morning, I don't do what our moms told us to do, which is hurry up and eat breakfast and catch the school bus to go to school. I get up. I take a shower, I get dressed, I take my time, I go for a walk, or I'll check my email or do something else. I'll wait an extra hour before I eat breakfast, okay? Now I've gained an extra hour. So the 8 hours of sleep plus the 3 hours the night before, 11 hours plus 1 extra hour in the morning, I have just spent half my day burning down extra fuel. Super easy. You want to go intense, you want to go 16 hours and squeeze it down to 8, go for it. But 12 hours works as well. I'm just trying to tell people easy, practical, delicious ways to do it. And then if you want to go hardcore, go for it.
What are the things that people have gotten confused about when it comes to fat metabolism? What are the top misconceptions?
I think, it starts all the way back to how we think about our bodies and metabolism and body fat and how they're all kind of intertwined. Because all of us have had this experience where you step out of the shower in the morning naked, and out of the corner of your eye, you see the mirror and you see a lump or a bump that you don't want to have there. Then you step on the scale.
I never do. What do you mean?
And the point is that, we wind up cursing, I think, body fat, and we start thinking our metabolism isn't actually working on our behalf. And that's actually just completely incorrect. Our body fat and our metabolism are so tied together in ways that give us health, generate our health. And what I write about in my book, Eat to Beat Your Diet, is really the new science of the metabolism, some of which is only 24 months old. It is brand spanking new research that is changing and upending everything we used to think about human metabolism and how that connects to body fat, good and bad. And then the really exceptional part of this is that, guess what? We don't need to fear our food. We can actually love our food in order to be able to up our metabolism.
What are the ahas? What are the take homes that people listening can use to start to upgrade their diet and optimize their metabolism?
Here is a really basic one that teaches us that Mother Nature is really clever. Very rarely does she have one system do only one thing. Usually, if you do, systems will do multiple things. So in my book, Eat to Beat Disease, I talked about the microbiome actually helps you speed healing, communicates to your brain, your social hormones, helps influence your immune system. Well, the microbiome actually is a critical regulator of metabolism, helps metabolize lipids, blood floating around your bloodstream, and how your body uses glucose as well. Now, not surprisingly, and some people may have heard me talk about this, in fact, on your podcast, we're now discovering, cancer researchers are discovering that there's certain bacteria that when present allow your body to respond to cancer treatments so you have a better outcome. And one of them is Akkermansia. You and I've talked about this before. Pomegranate juice, Concord grape juice, cranberry juice actually helps to grow more Akkermansia. It has to do with the elagitannins, these natural chemicals that cause your gut to secrete more healthy mucus that this bacteria, Akkermansia, loves to grow in. Now, what's interesting is that when this is a big study done like with 10,000 people in China, people who actually are heavier going into overweight to obese actually have less to no Akkermansia in their gut.
Wow.
People who are thinner, leaner, lean body mass, just because you're skinny doesn't mean that you don't have body fat, but people who have low body fat actually have more Akkermansia. So Akkermansia seems to be sort of this conductor of metabolism, body fat regulation, glucose homeostasis as well. Immune function, and inflammation, cancer development. I mean, just so profound. And so this is just one example of a single bacteria. And we've got 39 trillion bacteria. So we're just at the tip of the iceberg. but this is actionable. So, certain foods that contain elagitannins, like pomegranate juice, Concord grape, cranberry, those polyphenols that are found, those natural chemicals found, polyphenols found in those fruits, actually stimulate the growth of more Akkermansia.
But you don't want to be eating grape juice.
But you don't want to be eating a lot of grape. Well, so that's the other interesting thing, is that, this is another interesting metabolism dig in. So if you can actually have an orange, should you have a lot of orange juice? Well, there's fiber in oranges, there's vitamin C, there's a lot of hesperidin, narogenin, a lot of good bioactives, but there's also a lot of fructose in orange juice. In fact, you need 2 large, juicy, ripe oranges to make, you need 8 of them to make 2 cups of, two glasses of orange juice, a tall glass, right? Now, when would you sit down to eat 8 oranges? No. You wouldn't. You would eat 1 orange and get all that other the healthy stuff along with the orange. And so this is why, fruit juices, as a general rule, are not as good a choice for your metabolism than going for the whole food. And this goes back to the whole food, because juicing itself, it's a kind of processing, right? And then you filter it, you're filtering out all the good stuff too.
So this is so great. So there's all these different foods, we write about them. I want to talk about something specific, because I'm writing this book on longevity called Young Forever. We've both been to the blue zones. You just came back from Greece not too long ago. So did I. And there's all these different hacks. Now, we know that calorie restriction, meaning eating a third less calories, can make you live a third longer. And that's been proven in animal model after animal model. But who wants to do that? You're going to be grumpy and irritable and not the best friend around. But what you've discovered in your research is that there are hacks. There are food compounds that mimic caloric restriction. We call these adversity mimetics. They mimic adversity, but you get to eat them. So you're not really having adversity. Can you talk about that? Because it's such an interesting area of research where we're actually using the intelligence of plants to help us regulate our biology in so many good ways that extend life. And I don't know if you've read the book How to Change Your Mind or seen the new Netflix series by Michael Pollan. I've been watching that, and I'm like, wow, the intelligence of these plants. Think about it. There's you take a dose or two of psilocybin, and it literally relieves depression and OCD and all these things that you could struggle with for years and years, and is revolutionizing psychiatry from these molecules that have been embedded in plants that regulate our biology. Not all of them are psychoactive, but they're all bioactive, and that's what you write about.
Right. Well, I think that's such a good point you're bringing up, which is, in many ways, if we think about ourselves as a species living on a planet, and that we're constantly communicating with things around us, and plants and animals are also communicating back to us. It's this continuous feedback loop that's actually going on. So, this is you think about these bioactives in whole foods. They are Mother Nature's way, a plant's way of communicating to our bodies, right? And so that's really quite profound. And what's interesting is that many of those healthy plants that we already know about, tomatoes, the brassica family, broccoli, bok choy, kale, they all have these sulforaphanes. Then the sulforaphanes activate your white adipose tissue, the bad fat, that hungry fat, and actually starts to slow them down, shrink them down, and direct them into a different direction to become more brown. Brown fat, actually, by the way, so big bulging fat, right? This is the life preserver you throw off the boat to rescue somebody. That's the stuff you don't want around your waistline. Well, it turns out that the healthy fat, the brown fat, the burnable fat that burns out energy, is not a lump. It's very thin, and it's woven like a seamstress between your muscles. Wow. Amazing, right? And so
brown fat is woven between your muscles.
Yeah, it actually sits.
I thought it was just between your shoulder blades and your back, but it's everywhere.
There's oh man, this is such an interesting story. I got to tell you, viewers and listeners. So way back in the 1800s, 18th century, a biologist, a naturalist in Switzerland, Konrad Gessner, was finding these rodents in the mountains of Switzerland and dissecting them, and they were hibernating animals. And he found this thing between their shoulder blade, and he called it he said it's neither fat nor flesh, but it got bigger in the winter because he was catching these guys while they're hibernating.
Oh wow!
And what later on was discovered in the early 1900s is that, actually it's a kind of fat. It resembled a sort of a fat. And then when they jumped forward and found it in babies, they actually found that, so in these rodents, it was right between the shoulder blades. It get bigger during the winter, and it would actually shrink during the summer. And people are saying, well, how come these animals don't starve when they're hibernating? It's because that they're building up these things. And this is a heat generator. This is their space heater. And it was actually fueling up their metabolism. Babies have it too, right between the shoulder blades. And for a long time, the medical community thought, this brown fat's like an artifact from evolution. It's like an appendix. It doesn't have any real use. Hey, look, we have sweaters. We've got indoor heating. We don't need that brown fat to heat us up anymore. Turns out, this is a super fascinating story. There was a 67-year-old patient. that came to a Boston hospital, Mass General Hospital, and had a tumor in her chest. And so they were doing a PET scan to look at it. So a PET scan, for those of you who don't know it, actually measures the metabolism of a tumor. And so cancers will light up because they're really active, fast dividing cells. When they scan this patient's chest, the tumor lit up like fireworks. So when they biopsied, guess what they found? They didn't find cancer cells. They found fat cells. And when they looked at the fat, it was brown fat. Okay. And they were like, whoa, this is crazy. So they actually called it a hibernoma. All right. There's a whole tumor category that's based on Conrad Gessner's little rodent discovery of hibernating animals. So pathologists used to call this hibernomas, okay, when they used to find them.
Wow.
So this radiologist went back, okay, and looked at 1,000 PET scans taken from adults in Boston for different reasons, all kinds of different scans. And he found that people are lighting up, that this brown fat was lighting up in different places and different times. It goes one step further. Remember, I told you these rodents are hibernating in the cold, right? In Central Europe, like around Switzerland. It's pretty damn cold in the wintertime there.
Yeah.
What he found when he looked at the date of the scan, when did the scans, the scans that lit up with brown fat were all done during the winter months in Boston. Cold temperatures light up your brown fat.
Yeah, I know that. Yep.
So then fast forward. So we now know that we've got a pretty substantial amount of brown fat. And when they look at where it is, it's not just behind our shoulder blades. It's around our neck. It's around our girdle. It's up behind our chest. There's some in our belly. And cold temperatures and certain foods will light it up. And that's kind of like the cool part. The bioactives in foods will mimic these temperature and other factors to really help us burn fat.
That's amazing, William. I actually just in my book research on longevity was researching about hormetic therapies, which are stresses that don't kill you but make you stronger and better. And this whole idea of cold plunges and ice baths actually is one of those things. And that's one of the things I discovered was about the activation of brown fat, which literally speeds up your metabolism.
That's right.
But also discovered this concept of phytohormesis. Now you say these plants develop these things that work with us. I think that we need to frame it a little bit differently, that there's more of the symbiotic adaptation that we've had to these plants. They didn't make these chemicals for us. They made them for themselves as their own part of their defense mechanisms to deter pests, to deal with heat, to deal with sunlight, to deal with drought. I mean, just to be stronger. But we borrowed them for our own use because we're lazy biologically. Like we don't make vitamin C because we can get it from the food we eat. So we actually don't think of these things as essential nutrients, but I think they are. And they now can mimic these things that we need that are little stresses in our body. So a high dose, for example, will cause potentially some toxic effect. But if you eat them in the right dose in your foods or in the right dose in supplements, they can actually activate these pathways in the right way.
So so this whole idea of food dosing and hormesis, I love that you bring that up because that is such an important construct that, anybody in the medical community will know that the teaching of the drug companies is that a little bit's not enough. And then you want to increase the dose until you get the maximal tolerated dose. That's how drugs are developed. That's how chemotherapy is developed. How much can you how high can you make the dose until you basically make the person croak? That's really how drugs are developed. And yet that's not how biology is. When we eat those, when we have that symbiotic relationship with plants, which I totally agree with. And by the way, humans aren't the only ones that do this. Bears go out and forage for berries, for specific kinds of things. Insects go out and look for specific types of plants and pollen to be able to service their own systems as well. So, we're all taking tearing a page from the playbook of every other living species on the planet. Yeah. And at the end of the day, it always goes back to the plant-based foods. But here's, I think, what's really cool. We can actually think about this hormesis concept is so important. A little might not be enough. A little bit more might be better. Even more might actually get you where you want to be. And then when you go way overboard, you actually get less of an effect. And by the way, this is a lesson I think that people need to hear about dietary supplements, right? Because
Mm-hmm.
you get your quercetin, you get chlorogenic acid, you get your lycopene, you get your whatever it is. And, you know, the thinking is for a lot of people who are not savvy to the idea of hormesis is that more isn't always more.
Yeah.
At some point, more is less. May not be toxic, but you might actually move away from the benefit that you would get from it.
Yeah, it's really fascinating. It's like, what's the Goldilocks dose of all these things? And we can actually start to use these things to regulate our biology and our metabolism in ways that you're discovering through all your research, which is so important. Because I think as a doctor, you know, we don't think about these things. I don't think we think about the power of these compounds. And, you know, in fact, in your book and in our conversations, you talked about this incredible way in which often these compounds work better than drugs. And I remember this one slide, we were at a Milken conference together, and you were presenting to like the food companies and everybody. It was great. And you threw up this slide and said, here's a drug for high blood pressure, and here's this food, and here's the effect. And I'm like, wait a minute, I've never seen that before. And it was so profound. And we see that. We see when I use food as medicine with my patients in my practice and understand, you know, like any pharmacology, you have to know the right drug in the right dose and for the right person, for the right problem. And it's literally that specific. When you do that, you see results that are far more profound than what you see with regular medication. You reverse diabetes and heart failure and kidney failure and liver problems and autoimmune diseases and digestive disorders. And I saw it in myself. I mean, I had a, you know, incurable autoimmune disease, which I developed after getting C. diff, which is a terrible infection. I developed ulcerative colitis, and I was having 20 bloody bowel movements a day. I lost 20 pounds. I was in bed. I couldn't work. And I was like, oh, this is terrible. And actually, in part due to our conversations and what I learned from you about the power of akkermansia and other things, I tested. I had like zero akkermansia, like zero. And so I developed this akkermansia shake, which I did based on a lot of things I learned from you and research. Yeah. And I started taking it and actually reset my whole system. And I did a bunch of other things, but you know, we now can use these compounds as part of a therapeutic framework and understand that food really is medicine. It's not just like medicine.
Yeah, well, you know, so I'm working on my next book right now, which will come out next year. And what I'm doing is taking everything that I started in my first book and diving a lot deeper into how these many of the same foods and some new ones can alter our metabolism as well. But the big eye opener for me as a scientist, and by the way, you know, for people who are not scientists, the fun part of being a scientist is we get to discover new things that open our eyes, drop our jaws, and make us actually kind of jump for joy because we've discovered something new. And so what I'm actually realizing is that this idea of reversing disease, which is what you've just described for yourself, which sounds miraculous when one says it, actually isn't that miraculous at all. It's really helping our body reset. It's like having that spinning wheel of death and you do a hard reboot. You got to do different things to actually get your operating system to go back to what it wants to do. I mean, at some point, you can actually go over the edge and you can't rescue the system. You got to get a new laptop. But actually, more times than not, we can actually do daily things. This is the food as medicine, the medicine we take 3 times a day that put the right stuff into our bodies, the right type of calories, the right type of micronutrients and macronutrients. And by the way, not to understate the fact that food isn't a cure-all, this whole idea of lowering stress. And by the way, you know, right now, post, you know, kind of like this whole pandemic craze and all the political and military upset that's going around the world now, you know, the monkeypox, and it doesn't, we live in a doom scrolling society.
I tried not to go in there.
And what happens though, and I think this is so important to hear, is that, you know, it's one thing that I found it helpful for me, because I was getting, as a researcher in different diseases, is I started to find myself looking deeper and deeper into what's going on, just like a researcher, and I inadvertently found myself doom scrolling. And so that's something that I think that we can knowledgeably not do. You can undo that by taking some time away. I'm sure, you know, so here's what I did. I went to the Mediterranean to do some research on food. It was a complete reset when I was just with sea, sky, rock, and elemental foods.
Yeah.
You know, I'm sure the same way with you.
Totally. Yeah. Yeah. It was a great excuse. I'm writing a book on longevity. I had to go to Korea, one of the blue zones, and I ate all the wild greens they had, the wild mushrooms. I ate their wild sage tea, which has the high levels of that lactic acid.
We were FaceTiming back and forth, and I was so amazed. But like when you share that experience with others, because you actually know what it's like. What I'm trying to say is that stress is something that we have to live with now. It's possible to unplug and find simple ways to go back to a simpler sort of regimen in our life. And some of that's just unplugging from information.
It's true. I mean, I literally don't really, I think if some big news thing happens, I'll hear about it and I'll look at it if I need to, but I just sort of unloaded my nervous system and it's like junk food for the brain and for your soul. And I try to stay away from it.
Ultra processed news.
Ultra processed news. Not even news. And all the good stories don't get told. So there's a lot of hope out there. And, I just want to spend the last 2 minutes kind of getting a little bit granular on how you would tell your patients to take this information about metabolism that you've learned. How do they begin to incorporate it in their lives on a daily basis? How can they kind of accelerate their healing, speed up their metabolism, and reach their health potential?
Yeah, no, listen, because this is my new deep area of research. I'm not going to go into the complex. I'm going to go for the simple things. Turns out for your metabolism that what you eat and how you live can actually help to restore the metabolism that you were destined to have born with, which is the same as everyone else. All right. So you're not doomed by your genetics. You're capable of actually restoring your own healthy metabolism. And if you listen to the Dr. Mark Hymans of the world, you can actually elevate them as well, which to me is an inspirational message that you can actually not just claw your way back to where you started, but you can actually even get better. To me, how do you do that? You do that by actually a lot of the common sense things that we over and over we've been saying. Eat mostly plant-based foods, whole foods, fruits and vegetables, nuts, legumes, healthy oils, avoid excessive unhealthy fats. All right. Yeah. Omega-3s, which come from seafood and seaweed, are also great complements. And look, I'm somebody who really enjoys food. I don't love to eat, but I enjoy food, and I love the traditions of food. It's okay to, you don't have to be a vegan to enjoy your life, and you should live your life. But what you need to do is that you're tending your own body's garden. So you need to make sure you're taking care of it most of the time. Taking care of it, of not only eating well, cooking it the right way. So, omega-3 healthy, a piece of salmon. Okay. If you deep fry it and turn it into fish and chips, it's what we do to our food, even at home, actually can make the difference between turning something that's good and making it better versus taking something that's good and taking it less good for you. So that's something it's in your hands. And then, of course, the simple things like staying physically active, getting good quality sleep, managing stress, those are all the composite things that those systems. We started at the very beginning of this podcast talking about all those molecular systems and the microbiome. Look, you don't need to memorize all the things that folks like you and I are uncovering. But what you do need to understand is that how you schedule your life, how you run your life has a profound effect, this domino effect on all the things inside. So do good things for yourself. Do a good deed for yourself every single day, 3 times a day, and while you're sleeping at night. That's the secret to actually helping your metabolism.
If you love that last video, you're going to love the next one. Check it out here. So we need to include these in our diet. So when I go to the grocery store, I'm going to get asparagus and artichokes and onions because I know these are prebiotic foods. They're going to help my microbiome. I think about it. Or I'm going to buy jicama and put it in my salad because it's a prebiotic food and I want to actually increase the food